alive. Feel the wind.
All right. All right, all right, all right. Welcome to the second day of IglooConf. Now this day is Friday, and Fridays are good, so we have a good day ahead of us. And welcome to the stream as well. Happy to have you on board for this day of pretty filled stuff. Now if you look at today's schedule, we have Stacy first. She's ready to go. And then we have lunch and snack, of course, and a bunch of stuff in between. But you can see in the afternoon, we have only 5-minute breaks. We wanted to condense it a little bit so that we could end 15 to 5. We felt that that's better than 5, so you save like 15 minutes. But that's going to be, I guarantee you guys will feel it after today that there's going to be a lot of stuff. And Alan will probably end this day with a bomb. Not a literal real bomb. I meant like a heavy load of information to. Okay, cool. So, had a good night, everyone? Yeah? Did you have a good night? Yes. Excellent. All of these international people, I've asked a bunch of them, how was your night? Did you sleep well? No. They're like, goddamn sunshine, waking up at 5 and then it's sunny and, Glenn went to have a jog already. He went running this morning. That's just insane. I'm very proud of you. Well done. Let's give it to Glenn. Well done with the running. You were a little bit begging that, but I guess that's fine. So, second day is just like yesterday. We have all the stuff here. We have the sponsors, speak with them. We have the lunch here. We have the snack there. And if you're confused, ask a friend. Or come to me or Pasi, can you raise your hand? Pasi's over there. Very happy to see you again today. Yesterday was amazing. And let's make this day the same kind as well. Let's welcome Stacy on board. Woo.
Good morning, everybody. Welcome to day 2, if my computer recognizes me. It's always good when you start and your computer goes, nope, I'm going to go to sleep now. Come on. So, isn't this a start to the day that you wanted? It was just working. It didn't like my computer going to sleep. You really don't want to see me dance. You really don't want to hear me sing. Anybody here know anything about computers? Nope. Do you want me to try a different adapter? Yeah, it's full HD. Woo! Now this is fun, because this means I've now got to set up my screens again, so give me just 2 seconds. Come on, mouse. Oh, that's good. I've got plenty of time then. How's everybody's English? Can you handle me talking about this pace all the way through to make up for lost time? By Jove, I think we might have it. Yay! So, as I say, welcome back to day 2. It feels awesome to be able to kick off day 2 here. We had a superb day yesterday, and I can't wait to see Alan's slide at the end of today to see just how far this thing goes. So, I want to talk about static web apps today with you. And it started for me about 2.5 years ago when I was in bed. And I saw a tweet on my timeline compass that said, if you're blogging and you're using somebody else's site, doesn't matter how good that site is, I use dev.to and I love it, but you're using your time and your effort to build up that site rather than building up yourself. And it kind of resonated with me. I thought they have a point. So I grabbed my laptop and I brought myself a domain name. Actually, I brought myself 3 domain names because who can ever stop at one? So I got stacyclouds.net, .dev, and .com. And once I had those domain names, I did absolutely nothing with them because buying a domain name and using a domain name are kind of 2 different hobbies. My issue was that I wanted to not just install some blogging software and have my own site. I wanted to use it to play and to learn and to do things. So I was going to write my own blogging site. And that's a bit of an issue because I've got to design it. I've got to store the blog posts, display the blog posts, edit the blog posts, put authentication on there because I only want me to edit my blog posts. And it all started to add up, and there's just not enough hours in the day. I was busy enough, and so it sat doing nothing. And then I started to play with Blazor, and then I started to play with static web apps when they came out, and I started to see possibilities. Maybe I didn't have to build this absolutely amazing application out of the box. Maybe I could just play and get started. So that's what I did. I built myself a Blazor WASM application that reads my blog post from dev.to and displays them. I've got Azure Functions on the back end to do that, and slowly build it up as I have 1 or 2 hours. And then the static web apps make that deployment really easy, because you have the static files in the front end, you have Azure Functions on the back end, and you have all this awesome glue in the middle to put it together and make it seem like it's just one coherent application and not a range of Azure resources that you've got to arrange yourself. So I started doing that. My static web app, these Azure Functions, to tell the world who I am. So hi, I'm Stacy Cashmore. I'm Tech Explorer DevOps at Omniplan, based in Amsterdam in the Netherlands, and we make financial advice software. I've been programming since around the mid-1990s, and for the last 2 years, I'm really honored to be able to call myself a Microsoft MVP in developer technologies. Now, enough of me talking. Let's do some coding. Now, what we're going to do today is build that first step of the app that I was talking about. So just getting the blog post from dev.to just so that I can list them on my site. And then we're going to skip forward a few steps, and we're going to take a look at authentication. So the first thing that we need to do is create our application. And for that, we're going to make a Blazor application. So new project, Blazor web app. And we're going to call this client, only because I need to hook it into my GitHub repo. We're not going to call the solution name client. We're going to give it a really boring Blazor Talk demo title. We're going to be doing .NET 6 long-term support. We're not going to wire up authentication yet. We're going to do that manually in a minute. And we're not using an ASP.NET Core hosted app because I want those static files to deploy. I don't want any web server behind it. So now we have our app, we can add our API. So that's going to be an Azure function, of course, and we're going to call that API. You'll see why I'm using these names in just a couple of seconds. And I want an empty one because I want to do as little cleanup of my project as possible, which is going to be the first thing we do, because when you scaffold a new Blazor application, you get lots of cool pages to show you how it works, but I don't want to deploy that. So I'm going to just get rid of some sampled data here. And then we're going to get rid of the pages that we don't want, that counter and fetch data. Get rid of these. And then we're just going to make a couple of changes to the shared, because I don't want the link to the ASP.NET documentation either. And the 2 pages that were just deleted, they kind of have a navigation links to them, and they go nowhere anymore. So this is our base application that we're going to start building. The next step is to add some data to this. So we're going to start with the API. And the first thing we're going to do is make a model to read the data from dev.to. So let's just make a new folder here called models. And we're just going to bring one in called blog post summary. That's what we're going to get back. So new class. Now, I've got a load of snippets to bring over here because you don't want to spend the next 45, 50 minutes watching me do typo after typo. And if you do, don't worry, I've got some command line stuff to do, so you'll see them anyway. But for now, for the big stuff, we're just going to bring in some snippets. Now, this is just a really simple class. It's just my blog post summary, how I want to send it to my client application, with just some JSON property names, because what I get from dev.to is just a little bit slightly different. And then with that model, we're just going to make a new Azure function. This is where the fun stuff happens. We're going to call this blog posts. And we want a HTTP trigger. Don't forget to do that, Stacy. And then here, all I'm doing is on a get route, so get method for blog posts. All we're going to do is make a HTTP client with a couple of interesting things that you need to do to get dev.to to work. If you don't put certain headers in, you don't get data back. They changed that after my site was live, and I suddenly got an email from somebody saying, do you know that you don't have any blog posts on your site anymore? And then all we do is get our articles. The dev.to website has some amazing APIs on it, so you can really get all of your data out of there. So if you call API/articles and then give a username, I'm Stacy_Cash, then you get a list of all the summaries back so that you can display them as you want to. So we're going to deserialize that into the summaries that we want and pass it back to our client. And that is our API finish for now. Then we need to build the front end. So again, I need a model here. And full disclosure, in my actual application, I have a shared project here for between the API and the client for the model, but that takes longer to do than just to quickly repeat some code, so I'm cheating here. And we're going to add a new class here. And this one's going to be blog post summary again. And it's going to look very similar, just without those JSON property names, because I don't need those for the data coming from my API. And then finally, for this step at least, we're going to make a service. And this is what's going to organize our data inside of our Blazor application. So this is not only going to make that call out to the API, it's also going to cache that data so that we're not making that call every time somebody requests this web page. And then we just need some code here. So what this is doing, we are injecting a HTTP client. We get this out of the box with the Blazor application. And we have a public list of blog post summaries. This is what the different components are going to be using to read the blog posts. And then we have one public function, load summaries. And what this is going to do is just say, if I don't have any summaries, I'm going to go out and load them. If I do have summaries, fine, I'll just quit. And yep, this does mean that in the beginning, if you add blog posts or anything, you're going to have to refresh the whole page to get new ones. But for the first pass, it kind of works. It's acceptable. And then we just need to add that to our services in our program.cs file. And of course, control dot to bring in those using statements. Next up, we actually want to show these on the screen. So I'm going to make a new page, which is going to be a Razor component. And I always find that interesting. It's not a Razor page in Blazor. It's always a Razor component. There's I say all pages are components, but not all components are pages. And we're going to call that blog posts. So the thing that turns a component into a page is actually this directive at the top. It just sets the URL where the page is going to appear. Then we are injecting our blog post service, and then we just display it on the page. So if the summaries are null, we assume it's loading, so we just display a loading sign. And otherwise, we just go through each of the summaries and put it on the page. And the only thing we have is on initialized async, when the page loads, we go to that service and say, hey, make sure you've got some summaries for me. And really, the final step in this first bit is to make sure our users can reach this page, because I don't want them to have to type in my domain name / blog post in order to reach this page. You want to make it easy for people sometimes. And for that, we just add another nav link that just goes back to our blog post pages. And with that, I have my first pass at my application. So we're going to push this up to Git now. We've added the app. Commit all and push, and then we can see what we need to do inside the browser. Once this goes, come on, Wiffy, you can do this. Thank you. So this is my GitHub repo, which was empty. Now has stuff in it. This is good. This means we can carry on. And inside the portal, I've already got a resource group set up for my static web apps, and we're just going to go through creating one right now before we then see how we can run it locally whilst it's deploying. So let's create a new one. Let's search for static web app. Create that. Make sure the subscription resource group's right. Interestingly, this should always be right because we created it from a resource group, but I noticed in the last year, there's 1 or 2 resources in Azure have a bug in them, and it doesn't matter where you create it from. This is empty, and if you just click go, it creates you a nice resource group, and you've got no idea where your resources are. We'll give it a name, IglooConf. The name of a static web app, I quite like this. It's, as opposed to a standard app service, which has to be unique within Azure because that makes up your URL. For a static web app, you can use whatever name you like as long as it's unique inside of your resource group. Azure's going to come up with a URL for us, which makes our naming conventions hopefully somewhat easier in the future. Then we have to pick what plan we want. We're going to start off with free. This gives us a range of functionality, so we get authentication out of the box with role-based access management, with staging environments, using CI/CD that it's going to create for us. If you need a more enterprise solution, so custom authentication, private endpoints, etc., then you can go for the paid version, which is a humongous €10 a month or something like that. They're ridiculously expensive. I come from the Netherlands, so I'm going to base mine in West Europe. And as it says on the screen, this is only for the Azure functions and for your staging environments. The static front end is globally distributed by default, so you get that everywhere. And we just need to set up where our Azure functions are going to run. Then we need to set up the deployment details. We need to do this because it's going to create us a CI/CD flow out of the box. If we use GitHub, and I believe these days, Azure DevOps. You can deploy it from anywhere else, but then you're on your own with your deploy flow. You've got to make it yourself. Mine's all on GitHub, so I'm going to leave it there. So I'm going to pick my repository. And we want to deploy our main branch. Then we have to say what we're going to deploy. Now, static web app is, well, basically, it just serves static files. So as long as you can generate static files, you can use it. But it has presets for most of the popular ones, like Angular, Blazor, Next, Nuxt, React, Svelte, Vue, Gatsby, Hugo, VuePress, or your custom other if you just want to do your own thing. We're going to be doing Blazor today. And here's why I call my application client an API, because it's the defaults and it just makes life just a little bit easier. You can change this to whatever you want. The output location, if you're deploying Blazor, ignore it. It works out of the box, as long as you don't already have that directory in your repo. If you're doing something like Angular or Vue, it's a little bit more complex. You have to figure out where the build process is going to put it on the disk so that you can actually pick it up. But most of the time, it's not too bad. So now we can create this. And static web apps, when you're practicing your demo, are really quick to create. They come up generally in just a few seconds. A few seconds? Yes, thank you. And then we can go there. And here's that URL that I was talking about. So it's just made as a URL, Blackwater OC 554F45F03.1, really memorable. We have a link back to the GitHub repo where we deployed from, and we can even see all of the action runs for this static web app. So if we open this in a new tab, we get your Azure Static Web App is live and waiting for your content. And that content is going to come from this GitHub action run. It creates a CI/CD flow out of the box for us that will get the repo. It will trigger on a change to main. It will build our front end, our functions, bundle them up, and put them out, which I really love, because if you're just playing with this, then it's just something that you don't have to think about and just happens. But you can also override everything in there, so you can actually make it as, I want to say complicated, but that's not quite the right word. But you can tailor it to your needs as much as you need. Now, this is going to take about 3 minutes to deploy. So whilst we're doing that, I want to show you how to debug it locally, because, of course, in the cloud, in Azure, we have all of this glue putting the front end and the back end together. On my local machine, I don't have that. I don't have the Azure resource running. When these things were first released, when they're in preview, the way that you actually had to debug locally was add several files to your application so that when you're running locally, it did something ever so slightly different to what it was doing in production. These days, we can actually do something different. We can use a Azure Static Web App CLI, which went into GA just last month on the 19th of May. And that will replicate that glue for us using a Node.js server. So the only thing that we need to do inside of our Visual Studio is make sure that everything starts up when we click play. So we're going to want the multiple startup projects. We want to start both the API and the client. And then when we spin that up, we hope that I've not done anything wrong creating all this stuff. We have our Azure Function Core tools starting up. And we have our application. And if I go to blog posts, I'm going to get that error message because it doesn't know where to find my API. So if I go to a terminal, I can now run the .NET CLI start command. Now, the .NET CLI, it has loads of different functionality. You can sign into Azure, you can deploy your static web apps, you can initialize new repos. We don't have time to cover all of that. That's literally a talk on its own. But what we're going to look at today is just how to quickly use the start function so that we can get going locally. First thing we need to give is a location of our client application. And what the Node.js server is going to do basically is just proxy all of the calls from whatever URL it's going to give us to this location. Next thing that we have to do is tell it where it can find the API. Now, this is really annoying because up until about 3 weeks ago, this was defaulted to 7071, and you could ignore it. But in the last 2 or 3 weeks, I don't know if it's my machines, but all of my development machines now start Azure Functions on random port numbers, so this no longer works out of the box. We have to just do something slightly different. So I need to get my port from here, 7227. And when I said it's going to take everything that we put to the URL that it gives us here, 4280, and send it to that client application, I lied, because it's everything outside of those glue URLs. So the API is going to go to the API, and it has some other stuff that we're going to look at later. So this is running, and if I come back to my browser and go to localhost, there's a typo. 4280. Cool, it dies. Why did it die? What did I do wrong here? I know what I did wrong. I started it on HTTP. No, I did start it on HTTPS. Let's try that one again. Isn't it fun? I have never had this this error before in, Open DevTools. I've had different errors. I've never had this one. Sorry? It is. The computer obviously didn't sleep last night either. 7251. 7251. Okay, that is really weird. You know what? I'm going to show you a different application, and you're just going to have to believe me that this one works. Where does this one? This one should be okay. Run all. So this one's actually going to compile my website. And we're going to get a different one here. I am going to try and find out what happens to that. I'll put it on Twitter next week if I can figure it out for you, just so you know what's going wrong. And of course, I've got to stop the other static web app first, because you can't have two running at the same time. No, it is stopped. Apparently, I didn't pray to the demo gods enough this morning. There we go. No. OK, we may have to skip the local demos and just have a look at it running in production in a second. Because apparently, this is just really not happy. And I don't know if Windows Update has done something strange or what, but we'll see. Let's try one last time. Let's try it in a different terminal window. No, that's not going to work. Nope, I'm really sorry. I'm going to have to skip the local demos and just look at it working in production. I apologize for that. On the bright side, whilst we've been, looking at that and I've been swearing to my computer a little bit, we have a nice green tick here, so we should at least be able to see it running here. There we go. I now have my blog post from dev.to nicely listed in my app, and if I click on a link, I get it opened in dev.to. And this was literally the first part that I did when I started creating my website. Now, I'm going to skip forward just a little bit. The next step that I did on my personal website was to actually display the full blog post locally. But more interesting is actually editing them locally and storing them locally and not doing anything in dev.to anymore, but just all having it on my own environment. For that, we need authentication. Now, I am not an authentication person. I'm seriously not an authentication person. We have somebody for that in the office, and he's awesome, and I thank him for it. Thankfully, static web apps actually have us covered pretty nicely here. Some of that glue is actually built-in authentication. If we go to .auth/me, then we get a JSON object back, client principal, and it's null right now because I'm not logged in. Now, you've seen me create this code. You've seen what I put in there. And there is nothing to allow me to do this. That will take me to Twitter. It will log me in, ask me for my consent to use my Twitter information. And now when I come back to my site, I am now, hopefully, if Azure does its thing. It's early morning, isn't it? There we go. I'm now logged in. Can't see anything in the site yet because I've not built it. But if I now go back to that .auth/me, I now have a filled client principal. Is that visible at the back, or do you want me to zoom in? Cool. So we have a client principal here, and the first one that we have is the identity provider. How did you log in? Now, I use Twitter, but out of the box, we have Azure Active Directory, Twitter, GitHub, and Google. Then we have the user ID, and I'm not doxing myself here because every static web app that you make, you will get a new user ID. So once I delete this at the end of the session, it's gone forever. My user details, and this is my Twitter handle. And this is also why I use Twitter to log in. If you use Twitter or GitHub, it's your user handle. If you use Azure Active Directory or Google, it's your email address. And then we get the roles that are associated with your account. By default, anybody who logs into your website gets anonymous and authenticated. And we can add new roles to that if we need special functionality for certain people. So let's see how we can use this inside of the application. Let's go back to our Visual Studio. And what we're going to do is add some new functionality to both the client and the server for basic authentication. So first one that we're going to do is create a new object in the client application called Static Web App Authentication State Provider. No, I don't want NuGet packages yet. That comes later. We want a new class, nice long name, and again, full disclosure, this should really be in its own project that we just access, and it should be split up nicely into different files, but time. And in here, we have 3 classes at the bottom. We have an authentication data provider, that is that object that we get back from that auth/me route. We have our client principal. And we have SWA claims, which you didn't just see on the screens there, because these are only available in custom authentication. Then I do need to add some NuGet packages to get rid of these red lines. Let's quickly do that. We need to install Microsoft ASP.NET Core Components Authorization so that we can use it. Don't install the preview yet. Install 6, because otherwise things go boom quite nicely. Say yes to everything, because nobody ever reads this. And hopefully these red lines should disappear in a second now. Hopefully. Thank you. So inside of here, what we're doing is creating an authentication state provider specifically for our Azure Static Web App. And what we do, first thing we need to do is get a client principal, get that object from the website. Because this is a Blazor WASM application, it runs inside the browser, which means that when we make the call to that auth.me endpoint, we're using all of the authentication cookies that the user has. So we can get this data back, and we can trust what the static web app is giving us. So we make that call, we extract the client principal. If there isn't one there, then we just make a new client principal, assuming the person's not logged in. The next thing we need to do is convert this thing, because a Blazor application doesn't need a client principal, it needs a claims principal in order to work. In order to make that conversion, first thing we do is strip out that anonymous role, because you know what? If somebody's anonymous, I don't actually care. I'm just going to treat them as though I don't know them. Then we see if they've got any roles left over. If they don't, we just return a new empty claims principal. That user is not authenticated in the app. If they do have roles left over, then we make a new claims identity based on the identity provider, based on the name identifier and the name that we get back in that client principal. And then we just add each of the roles that are left over to be passed back as a new claims principal. And that's pretty much it. Once we have this, we can then just make sure that this is available inside of our services again. So again, we're going to go into the program.cs, and we're going to add a new line with, again, control dot, just to bring up that using statement. And we now have authentication built into the application. Now we just need to use it. First one that we need to do, because it's a Blazor application, is make sure that we have a cascading security available to us. So outside of our router, we're going to add a cascading authentication state. Yeah. And this is just going to make sure that in any component that we call inside of our application, we can now get access to the authentication state of that particular user. And we're just going to add another using statement to this underscore imports. I love underscore imports because it keeps your components looking really clean. I know that other people have differing opinions about having global usings, but I adore them. And now, just to show how we can use this, I've got two things that I want to do. The first one is inside of our navigation. I just want to put a login link. So underneath my link to blog posts, I'm going to add an authorized view. And what this is going to do is allow me to see whether or not the user is authenticated or not. If they are authenticated, if they're authorized, and you can also limit this to authorized for certain roles, so you can have multiple authorized here. If you're authorized, then we're just going to give you the logout button. And we're going to check, are you a super user? If you are a super user, we're going to tell you that you're a super user. If you're not, then we're just going to give you a standard user indication. If you're not logged in, then we're just going to redirect to that Twitter login so that you can log in. The second one that I want to do is just inside the main layout, where we used to have the link to the ASP.NET documentation. We're just going to have a little something that says whether or not you're logged in, and if you are logged in, then what authentication type did you use? What provider did you use? Not necessarily useful, but just to give you an idea what you can get out of it. And last but not least, for the client application, I'm going to be adding a static web app config file. Now, this is a really powerful JSON file for Azure Static Web Apps. You can control your routes here. You can control your authentication here. You can control what authorization providers you want to use inside your app. We're going to be really simple today and just adding a few routes. So I want a new item, and we want that to be a JSON item. And static web app config.json. There we go. And I've got a little app here. So what we're doing, I'm going to make two APIs in a second. And one of them is going to be auth test, and the other one's going to be auth test 2 because naming is hard. And I want to make sure that the first one is only accessible to super users. Second one should be accessible to anybody who is authenticated. And the other one, for whatever reason, I don't want people to log into my app using Azure Active Directory. I only want them to use GitHub, Twitter, or Google. So I'm just going to say that special glue URL that you can't actually control directly, we're just going to return a 404 if anybody goes there. Finally, not to do with authentication, but super important, we have a navigation fallback. When you first deploy your application, if you don't have this navigation fallback in there, users are going to be able to click around your site and it's going to look awesome until they hit F5 or they bookmark a page. Because these pages, they don't exist on that server. So they're going to make a request to blog posts and the server's going to go, I don't know what a blog post is. You're going to get a 404 back and you're going to have unhappy users. The navigation fallback, that changes that. It sends everything back to index, so your page still loads, and then Blazor will take care of the routing, and you can get to the page that you want to go to. This doesn't happen out of the box, and until they started using this navigation fallback, you had to do some really interesting tricks using proxies and Azure functions and all sorts of other stuff to make it work for you. I'm really pleased it's easy now. So that's what we need everything in the client side. And the reason why we're putting the API authentication in the client side is because it goes in this WW route, so that gets deployed when you publish your app, and that controls the static web app. So let's clean up our tabs a bit, and now we can start on our API. First thing we need to do is to get access to our authentication. So we're going to add a new class, and that's going to be called Static Web App API Authorization, because again, naming. And this works ever so slightly different than on the client side. We still have this client principal in these SWA claims that I was talking about. Only now, we can't call that endpoint anymore, because we no longer have all of the cookies that we need for authorization. The way that this is solved is when a request for an API goes through the static web app, this XMS client principal header is injected into it. The user will never see this header. So it's one that we can trust, it can't be played with, and we can extract our data from there to use for the authorization and authentication in the backend. And here, all I'm doing just to show that it's working is just stripping some data out and returning it to the front end. But this is really useful if you want to know who is logged in so that they can only access their data or they can only edit their data. This is where you get that data from. I wouldn't use it for the full-on access control because the static web app API is way simpler and you're less likely to put a bug in there. So now we're going to add a couple of functions, this auth1 and auth2. Sounds like a Dr. Seuss book. So we want HTTP trigger again. We are going to bring across our function. And all we're doing is just, pass in the HTTP header for that client principal that we just looked at, and then just outputting that data back to the front end. And then we're going to do the same again, just with number 2. Functionality here is entirely the same. It's just purely what's in that static web app config file that makes the difference. And we're just going to change the names here so that it doesn't complain at us too much. And that's everything that we need to do for our authentication. So let's add auth. Commit all and sync. Save everything. Always fun when you forget to save stuff and then when it's deployed you go, oops. I'm too used to VS Code that just saves on as you type. So now if we go back to our Azure Functions, we have the second build kicked off because that's our built-in CI/CD that we got with the application itself. And this, again, it's going to take about 3 minutes to deploy. Now, I was going to demo this locally, but obviously that's not going to happen. So what I want to do instead is show you how you can make custom domains for your application. Because as much as static web apps come up with interesting names, I've had yellow beaches, red rivers, black water. It's not exactly catchy to kind of like sell your own brand. So we're going to put something much better on here. I'm not going to do that in the app that I've just made because I have to set up stuff in my DNS to get this to work, and that either works in 10 minutes or 48 hours, and I don't really think you want to wait that long. So I have one that I made earlier, and we're going to be, hey, that's new. Ooh. We can now do custom domains on Azure DNS. That is literally so new that when I ran through this yesterday, this option wasn't there. But we're going to use a different DNS provider. And we're going to go for www.stacyclouds.com. And what it's going to do is say that in order to make this work, you have to put a CNAME record in your DNS so that you prove you own it. I click Add Now. And that should just work nicely. If you don't have one, it's going to give one of 2 errors to you. So it's either going to tell you that the record is wrong, it's linked to a different custom domain or a different application already, or it's just going to tell you, nope, you don't have any records there. Are you sure that you've added it? This also takes about anywhere between 1 and 10 minutes. So this one's also a nice one to demo, because it's like, is it going to be there by the end? We can keep our fingers crossed and hope. How's that deployed in 2 minutes in? Go on then.
My question is now, you've been using Blazor. What's your take, or do you have any thoughts on the future of it? Do you see it being used in Netherlands or elsewhere? Is it receiving any favor with developers? And if you want to widen to WebAssembly, what kind of thoughts do you have on that?
So the question, if I heard it correctly, and if not, you can correct me, about Blazor and whether or not it's being adopted.
What's the future? Do you see it being used seriously by the industry?
Yeah, I already know several people that use it in order to do production websites, public-facing production websites. They're not using the WebAssembly, they're using the server version. In my company, we use the WebAssembly at the moment for our admin portals, because we're trying to gauge it. It's a nice one to use, certainly for the hobby sites. It's really quick, it's awesome. And we wanted to see what we had to do to actually make it work inside of, like you say, a real full-blown application. See whether or not we can use it in the future. The fact that it runs on WebAssembly, I think that's a thing that's really in its favor. It's not Silverlight 2.0, which is a question that you normally get asked, is this just another Silverlight? But it's not. It's running on a standard, and it's built into all the browsers by default. It's not a plugin. The biggest issue that it has is that first page load, because you are downloading the full-on .NET WebAssembly DLLs in order to get started. It depends on how much that first load time matters for your application to see how much of an issue that is. I've solved that on my own website by pre-rendering the pages. So I have a function that just goes through, renders all the pages, uploads that to the repo, and I've literally got HTML pages for each of my Blazor pages. So content might change if I add new blog posts and things, but there is something there already. You don't just sit staring at a load screen for an age. But if you've got an app like our admin app, it's fine. And to be honest, for our customer-facing app, loading all of the Angular stuff and loading the Blazor WebAssembly stuff, Blazor's slower, but it's not the biggest difference in the world. So I think it's going to be OK. Only time will tell. I might be completely wrong here. I might be Rick from 7 years ago. But we'll see. Right? You can get me back for this in a couple of years. So no, it's, yeah, we'll see. But it's quite nice to use. I've got to say, for C# developers, everybody in my office loves it. The Angular developer, not so much. But I think that's the same with any front-end application. It's you've got to make sure that you are using the one that you're comfortable with. I wouldn't tell any Angular developer, stop what you're doing and use Blazor. But I would say, yeah, take a look at what frameworks are out there and use the best one that works for you. You're welcome. Thank you. So now, if we refresh the site, we have this auth provider at the top. I can now log in. I will go back to my application. I'll go back to Twitter, come back to my application, and I am now a standard user. So if I now try and access my APIs, so API/auth test, and I get a 403 forbidden. Now, one of the things that I wanted to show in the local demo is the fact that this is not the same. I get a different error message in production than I get locally. There's a bug in the CLI. It returns a 401 instead of a 403. It just gives unauthorized for everything. And it's important because you need to know that that static web app CLI does not give you the Azure resource locally. It only replicates it, and they even say themselves, this might not match. Always test in an Azure environment before you actually go live. If I go to my auth test 2, yes, I actually get some data back. So you can see that this is from auth test 2. I'm Stacy Cash. I've got my user ID and these 2 roles. So we now have authentication built in, but I'm only a standard user, and I want to get access to that auth test, and I want to see super user just here. So we're going to do that using this role management. Now, this is built in. Out of the box, on the free version, you can set up, I believe it's 25 users with different roles. Doesn't sound a lot, but you only need this for the users with special roles. So for an amount of things, this is going to be good enough for you. If you need more than that, then you can buy the standard tier, you can pay money, and then you get 25 roles on this page. And I don't know why that's not different. But what you do get with the custom authentication if you pay is you can set up your own role provider. It's a separate Azure function. We're going to build one in a second. And when you get that working, then the sky's the limit. You can have as many as you want because you are in control of it. Right now, I'm going to invite somebody from GitHub. Oh, another important one. I stopped Azure Active Directory being used as a login provider for my site. I can still select Azure Active Directory here, send somebody a link, and they're going to get a 404 doesn't exist. So that doesn't talk to each other. So bear that in mind when you're inviting people. But I want GitHub, and I'm Stacy Cash on GitHub, and I want to give myself super user rights. And I'm going to generate a link that's going to last for an hour. And if I come here, let's log out first. Now I'm going to go out to GitHub. I still need to give my consent again, because it's the first time I've logged in with GitHub. And I'm now this super user. And that's how easy it is to get people into your site with special functionality. And now if I go to auth test, we get that same information back. It works for me. Woohoo! Small proviso, this is cached. There's a reason why I didn't add the extra role to my Twitter user, and that's because it takes somewhere between 5 and 20 minutes for this to actually get into the system, which is annoying when you're adding a role. What's even more annoying is if you remove a role, it still takes that 5 to 20 minutes before it actually appears on the site. So this isn't perfect. But again, for what it's aimed for in the free tier, for out of the box, it works quite nicely for us. So the next one that we're going to do is add custom authentication so that we can take this from a hobby website and we can use this inside of our corporate environment. So we're going to go back to Visual Studio. And we are going to add custom authentication. And this is a really complex change. The amount of code that you have to do is impressive. Inside of our static web app config, we just have to add a new node to our object. So what this does is set up our custom authentication, and it says, for my roles, I no longer want to go to the Azure portal roles. I want to use this function. And then we add our providers. Now, I'm going to be using auth0 here because it's just nice and easy to set up on the fly. And we have to figure out an ID and a secret. You don't put the ID and secret into the config file because you really don't want to put those into your code. We're going to set up configuration options for that inside of the app in a couple of seconds. And then we just set the schema, the well-known ID configuration, and push that up to the site. Now, if I wasn't using the custom roles, this is all you have to do. There's no actual code change to use custom authentication itself. It's purely a configuration option. But because I do want to use that custom roles, I'm going to have to add a new API. So we're going to add another new Azure function, call it getRoles, HTTP trigger again. And this one is a little bit more complex than the other ones we've had. Let's get rid of the Solution Explorer so we can see what we're doing. It's on a post. And we have to get the request body so that we can access it. And inside that request body, there is a client principal with all of the basic authentication data that we have, plus a little bit of extra. We'll see that once it's deployed to production. Fingers crossed we get there in time. And we can use that extra information to actually decide what roles our user needs to have. So now that we have this, this is all available on GitHub, by the way, so I'm going to also learn to speak. I'm also going to tweet the location of the GitHub so that you can actually try this yourself. So we need, I closed it, didn't I? I didn't just hide it, I closed it. So we've added custom auth, another typo, but we can live with that. And we're going to push that up, and we're going to do another rebuild. So let's check that that's actually going. Thank you. So while this is building, we're going to see what else we have to do to get this set up. First one that we have to do, and the one that I always forget and end up pulling my hair out about why it's not working, is we need to change our hosting plan. Because for custom auth, we have to use a standard app. We can't use the free tier anymore. But like I say, it's not the most expensive app inside of Azure, so it's quite reasonable to do. Once we've done that, we need to make our Auth0 application. So let's make a new one here. IglooConf. And here we're going to need that client ID and the client secret in a minute. But first of all, we need to set up some information inside of Auth0. We need to do the login URL, the callback URLs, and the logout URLs, which all have to start with this. And then we just have a little bit of information that we need to bring across. So our login is going to be login/auth0. So before it was /Twitter. When you're using custom authentication, it's just whatever you name it inside that static web app. And the callback URLs are just the same thing, but just with callback at the end. For the login and the logout. So save these changes, and then I am going to dox myself. I have my client ID, which I'm going to bring across to my configuration. Come on, Portal, you can do this. And that one needs to be, what was it called? My Auth0 ID. And then I need to add my secret. I am going to delete this secret as soon as I sit down. Yeah, take pictures. So we're going to bring our secret across, and that should be everything set up inside of our static web app. And now we just need to wait for it to be deployed. While it's being deployed, I mentioned before that CLI replicates what happens inside of your Azure Static Web App. It doesn't create it, and you need to test it inside of Azure. This doesn't mean to say that you need to push it out to production and do a test in production and go, please work. There is a really nice piece of functionality inside of Azure Static Web Apps that when you create a pull request, by default, we get a website made for us. It's a staging environment. It only exists in the same region as your Azure functions, but it's available for you to test in production. So what I'm going to do, I'm going to open this one up, and I'm going to open the original up. So in my original, in my fetch data, I have the very boring, very standard, this component demonstrates fetching data from the server. I thought that was boring. So in my pull request, I've changed that to, oh, the weather outside is frightful, because I did this when it was snowing outside. And actually, I'm at IglooConf, so it kind of works today too, even though it's sunny outside. So this is all set up by default. It's a slightly different URL. It means that you can test your application in a proper Azure environment, and you are going to see if things work or don't work as they would in production. Word of warning. If you are on the free tier, you cannot hide this from the world. So if you're operating on the free tier and you have got something that you cannot possibly let the world stumble across, I'm afraid this isn't going to work for you. You're going to have to come up with your own pipeline, deploying to 2 different places or something, and make it fun. If you are running on the paid tier, then you can add a password to all of your staging environments to make sure that only people who should access them can access them, which is probably a little bit safer. When you've finished your pull request and you complete it, there's another flow that starts that does all of the cleanup for you. So you're not going to be left with huge amounts of staging environments around the place that you don't know about. It's all sorted for you. And Azure Static Web Apps kind of force you to do this because there's a limit on the staging environments you can have. On the free tier, you can have 2. On the paid tier, you can have 5, I believe. How are we doing with our thing? Our custom auth is working. Right, let's see. Does this actually work? So if I click login now, it doesn't do anything. That's interesting. Why am I going to Twitter? Because I didn't change my login button, of course. That's good. If you had custom auth, well, at least I know the custom auth is working. If you had custom auth, then the standard ones no longer work. You only have access to the custom auth that you set up. So if I go to auth 0, I was already logged in, which is a shame. But I've now gone out to auth 0. I have got my information from auth 0. You can see that the provider's changed up here. And I can now access everything that I need to do as I want to. I'm not going to show you the auth.me page, I'm afraid, because that does now have personal data on it that I really don't want to put on the screen. But if you give this a go yourselves, then you'll be able to see just what you get back. And I think for an out-of-the-box, it's quite impressive how we're doing. I've got 3 minutes left. So the last one that we're going to do, the custom domain. So we now have this yellow border. So it's this application. No, that one is the pull request. So this application now has a second URL available to it, mystacyclouds.com. And in fact, if we go back to the overview, it even changes a URL for the application now to be your custom domain. If we open this up, I have stacy.clouds. I have a nice padlock in the corner because you get your SSL out of the box for your domain. And everything's working as it should do. So that's that. Well, that's not bad. All of the online demos worked. It was just the personal ones it didn't, which is, you know, nicely opposite to what it normally does. So then, we have, inside of around 45, 50 minutes, created our application, got our data from dev.to, displayed it in an OK manner. We can sort out the CSS later. We've looked then at what we can do to do pull requests so that we can actually check our changes before we go to production. We have added a custom domain so that people can find us easily. And we've even looked at what we can do for authentication, both out of the box and that custom authentication so that we can actually use it in an enterprise environment and not just as a little hobby site. This is only the start of how I built my application, my personal site. It's a work in progress. It will be forever, I imagine, because there's always going to be bits that I'm going to be changing as I go along. On the screen right now is a QR code that will take you to, I believe, MS Learn for Static Web Apps. If you've kind of like triggered by what you've seen, then take a look. And if you're not, take a look anyway, because MS Learn is absolutely awesome. And yeah, thank you very much for your time this morning. It has been absolutely amazing to be here. Thank you so much for inviting me, and enjoy the rest of the day. Are there any questions?
1 minute.
Are there any quick questions? Otherwise, I'm here all day. You can grab me and see whether or not I can answer them for you.
Exactly. Thank you, Stacy. And anybody interested in Blazor, go and bother her with those questions. We'll now have 10 minutes of break. So let's get back to 15 past. All right. The last of the stragglers are arriving. Everybody had a cup of coffee. We have one more information-filled session about data before lunch. So please have a warm welcome to Roberto!
Thank you. Hello. Well, let's give you some context. I was born as a developer. I used to be in the last 10 years, like 15 years. And 3 years ago, I started this journey around data, okay? And to give you some context, in the company where I work to in this moment, we have a big team of analysts, of data analysts, and we need to provide them a lot of data. Okay, so with my amazing team, we tried as developers to switch to our mindset with a data-driven approach, and we started from scratch. We started from relational database, and now we are on the data and Delta Lake. So this session is about this transition, about this path that leads me to the point we are now, and since my bias, my developer bias, is around the platform as a service, so we don't want to use VMs, we don't want to use infrastructure, I want to show how to do that with the minimum amount of infrastructure, so in a serverless way. So this was our journey. So we started from the relational database with tables, okay? So after a few months, probably, the solution didn't fit anymore because the data grew up, okay, a lot. And we tried to have some variations with JSON. So how many of you used JSON inside SQL database or SQL Server? Wow. Great. And so you probably know that's amazing because you just put your document, you don't deal with the schema, and that's all. With JSON value and OpenJSON, the rest is up to SQL, okay? But it didn't fit anymore after a while. So we tried to go with the data lake, and we discovered a lot of things. We discovered the concept of landing, so just use the data lake as a file storage just to land batch of data, okay? And then we tried to structure it by ourselves, so by making a partition strategy by ourselves, so directly organizing the files into the data lake to then go and approach right now to a mixed model where we have some partitioned data lake part and some other Delta Lake that is managed by Spark, actually, okay? So this is some glossary for the session. So data movement is the process to move a large amount of data from A to B, and you can have some challenges during this movement. For instance, if you are lucky, you probably work in a append-only environment. So your movement is just a difference, just incremental slice of data that comes out day by day. Okay, but if you're not so lucky, you should probably deal with the concept of updates. So the upsert in SQL, but so you just can't append, but you just need to update the existing data, and if it's in the data lake, it's not so easy. What is the landing storage? In our data governance framework, the landing is the storage that we used in the nearest part of the source. So it's very connected to sourcing. Sourcing is the process to get data from outside, so from an API, from somewhere else, okay? And typically, that kind of data is put into the landing storage. So it's not trusted yet, okay? What I mean with trusted, I mean that we perform some check around the data to put in a vault, okay? And this vault can be the database itself, the data lake. We can do with Spark, that is an open source technology by Apache, and it's the underlying technology also of Databricks. And there's the technology that we can use in Synapse, that is the tool we are looking at today, for big data. I don't even don't really have a definition for big data. It's data that's really big, but I have one for cloud. Okay. But we have so many definitions of cloud in those days. I really like the one of Magnus and Zachary, but definitely we have so many. But I really prefer the one by Mark, actually. Yeah. Well, let's go with the sourcing part. Okay. In this scenario of today, we have three kind of small data set. Okay. I don't even call dataset, they are just JSON documents, okay? That resembles the advertising word, so clicks, impressions, conversions, okay? And we want to put them into your data lake, data framework, data platform, okay? So data platform is the union of all this part of data management, movement, sourcing, and so on. So for this demo, we're starting from scratch, except the ingestion part. So I leave it on the GitHub, and that's essentially a C# application, okay, like this. So well, this is the entry point, and here I'm emulating the sourcing by generating some reports. Okay, so I generate some random reports that you can actually take from an API. Okay, but for this demonstration, I generate them and I write on the relational database. Actually, it's commented because it's the more time-consuming part, but I prepared it, and I performed 4 different write strategy. The one is in the landing zone, where the concept of batch resembles that you just take what is from the source and put in the fastest way into the storage. So no transformation, no logic, nothing at all. Okay, just put your data into something secure. That is your landing storage. And how I did that, just with the simple write to the blob storage with this pattern. Okay, so I'm organizing by myself the data lake. In this case, it's just a new document with a GID into this batch folder. Okay. The second strategy is with the partitioned data lake. So in this case, let's go into the details. I use another folder, and I'm organizing the structure into types. So the actual report type, and then here I split them into year, month, and date to have a more organized structure inside the data lake. Why I did this in this form? Because this is the standard that can be read by Spark engines to push up these parts as parameters. Okay, so when you work in a data lake with this convention, okay, you are working by setting those segments as segment parameters. So you can reuse them to filter out your data, and it's very effective. After that, I also tried another strategy that can be very interesting when your data doesn't change. So if you are in append-only mode and you don't have a late arrival that updates your previous data, you can go with an append strategy that can be made with the API. Well, okay, hey, stop it. Stop it right now. Okay. With this native API of the blobs, okay? We can say append block, and we can use just a single blob to append the data. Of course, this stays just for that kind of data that is text files, okay? CSV, JSON. So a JSON after JSON can be read as a JSON lines format, so JSON-L probably. CSV one after that is good, probably, but a Parquet file, one after that, is not really suitable. Even an XML is not really good, probably. So this very depends about your data format, okay? So in this case, since I'm appending, I'm not really partitioning for year, day, month, but I'm just pulling all together in a year JSON report, okay? And finally, I made the same thing of step 2, but with Parquet data format. How many of you knows Parquet? It's amazing. Okay, good. For the other ones, I would say that in this case, but through C#, I'm just changing the format. It's not really a good approach, just for the demonstration purposes. But just to be sure that you understand, Parquet is a columnar format to store your data. So when you have row store formats, you just have like 1, 2, 3 rows, and if you have a billion rows, and you want to make a sum of a specific columns, think about of the logic under the hood that probably scan each row, take the column, and then put all together to get the sum. Okay, with a column store that in SQL Server can be the cluster, the index, the column store indexes. The concept is that you just change the underlying storage format to organize all the stuff into columns. And it's really, really impressive in terms of performance with an analytical workload, because if you want to perform a sum on an aggregate operation, you just read the column, the single column, and then you just can be faster. And in 99% of the column store formats with Parquet, SQL, even Power BI and Tableau have their own column store formats. There's also a great compression in place. So when a raw store data set can be like 1 gigabyte, the column store version can be like 10 megabytes. Okay, so not really so huge, but real with about 20, 30 per of compression on average. Okay, good. So, well, I want to run this, and I want to, this is a prefix for my data lake, so everything would be pushed on this prefix. I go to Azure to take the connection string of the storage account. IC should stay for Igloo conference. Okay, good. And I try to run this one in the background. So, finger crossed that is generating some reports. Let's wait a second line and we can go ahead. Well, internet, please. Okay, good. It's generating. Where is generating? So, let's go now to Synapse. Well, Synapse is one of my favorite tools in the last couple of years because it wraps up all the stuff about data. So it's not only a wrapper, actually. It gives you also some unique features like the serverless pool that we are just looking in a few seconds. Okay. For instance, let me investigate our storage account in the reports folder. Now, a folder that is called IC has been created right now. And we have those 3 versions. Okay, the batch one, of course, is a collection of documents like this, so you can have just a preview. Okay, each one is an array of events. Okay, and then we can have the partitioned, the append one. So I mean that with the append one, I'm just partitioning by year, so just one document for an entire year. It's not really a real-world scenario, but just to be sure that you understand. And we also have the partitioned one. The rest of the demonstration will be focused on this partitioned one because it's already structured, already organized, well organized. Okay, so in this case, we have for each month, for each day, JSON version and the Parquet version, and you can see the difference in size. Of course, this is not really meaningful because if you have you see the difference when the data is so huge, so you can see the compression in action. Good. What is the really nice point of Synapse is that feature that's called a serverless pool. Okay, so when you have Synapse, you have embedded sort of DB. Okay, this one. Okay, that is also seeable by SQL, by the Management Studio, because it's TDS compatible, so you can connect it by SQL Server Management Studio, and this is one. This is not really a database, okay? It's something virtual that acts as a bridge between the SQL world, so the TDS world, and the data lake. So it's a bridge. in my personal definition and opinion. What I mean that if I generate a query like this that I take out and I put here to be well, not really. Okay. I'm telling this bridge to open this parquet with this format, okay. Auto-infer the column the types, and produce an output. So with this serverless pool, you just can connect to signups and get out the result in a SQL, in a tabular format, okay? But we can also do more, of course. This is partitioned, okay? So we can just say, hey, there's no a fixed year, month, or day, but we can have wildcards, and we can spend our wildcards, excuse me for the indenting, okay, spend those wildcards here with results dot file path 1. That is the first segment. I don't know if why it's one based index, okay, but it's the first segment of the wildcard path, okay. And we can also reuse like in a concat fashion, okay, 2 and 3, and we can have like a date, and we can also cast as date. And now it's slower because it's actually exploding the wildcards. So before that, it was just reading that parquet, that single parquet. Now it listed all the parquet inside the wildcards and read all the stuff and promote the wildcards into a parameter. Yes, can we reuse it in the query itself? That's be good, because if I can, if I put a where date is lower or greater than, the underlying engine will go just through the partition, just to the set that is of interest, okay, without scanning all the other millions of files that we have. So this is really a good value for your buck, since it's also very cheap, because it's the billing model, the pricing model is based on the actual data, the actual volume of data that you process. So if you process a huge amount of data, you pay more, but if you just use the bridge to read gigabytes of data, it's a fraction of $1, okay? And of course, we can use this approach also to read JSON. It's the same, and since the audience is already accustomed with the JSON format, I don't give too much details about the JSON value function that can be, of course, extract the values from your JSON documents. In this case, we can put a cross apply here to the open JSON to promote the array into single fields, and then we can take out some fields with the JSON value. And this is, of course, working inside our management studio, where we can create a view, for instance. So we can have a view, and you can even map in your application that view that seems to be a SQL view, but in reality is something that is hitting the data lake in real time, okay? So this is my, okay, well, it's continue generating, so we can stop it because we have some good data sets to start with. And this is the ingestion part and also the exploration part of our journey, okay? What we learn internally with this approach, that you can use the bridge, the serverless pool, to perform some sort of investigation inside data, and also to give those data to the outside users. One question may be, but is from the performance point of view, how is it effective? Okay, it's not really like a data warehouse. It's not really like a SQL engine, because under the hood there are files, okay? So you can imagine like a pool of machines that pulls up those files fast, but not so fast as another context. So don't expect to connect directly or your business intelligence to this one. Probably it works in some scenarios, but it's not so effective, okay? So after that, we had the challenge to consolidate our data sets, okay? And we had some alternatives, okay? One is the data copy activity in Synapse. How many of you knows what I'm talking about? Now a few, okay? We have many. Now we are going to investigate all of them, but data flows is something related, stays on Synapse, but is also related to Spark pools. So think about these three as the most high level and the most low level way to aggregate our data. And actually with Spark and data flows, we can have more and more than aggregation, okay? And we'll see later. We talk about the Synapse serverless mode, and just as a reference, we have also a dedicated pool in Synapse. The dedicated pool is just a former data warehouse in Azure, so just a relational database optimized for analytic workloads. And now it's called Synapse dedicated pool. Okay, we don't use it in this demonstration. Now I'm start to consolidate our data sets, our reports. It's not a data set yet. That's here. So as you saw, we generated with the C# application those three reports, okay? Let's take the first, the clicks. We have just 1 year because of the timing, okay? In this 10 minutes, generate just 2 months of reports, okay? And we want to wrap all the stuff in a single file. Why? It's not really, in the real world, you don't want maybe to wrap all your stuff in a single file, but probably you want to aggregate by month, by day, by I don't know, which is the aggregation that you want to perform. Okay, but in this case, just to be simple, we are aggregating all the stuff of a single report type in a one file. To do this, we can use a pipeline. Actually, it's a very simple pipeline with a copy data action. And here, do you see? In the back seats? Yeah? Okay. And here we use a new data set, the data lake storage Gen 2 that is different from Gen 1 because it's the new one and the only one that has a future, okay, right now. And that's the same of blob storage. So if for the people doesn't know the difference between data lake storage Gen 2 and the plain blob storage, is now it's just a matter of initial configuration. And the Gen 2 storage is actually the blob storage with a hierarchical namespace, so with folders, for instance, okay? And a protocol to go inside it without the necessity to use HTTP. That is the difference that made it really fast for Hadoop technologies. So let's read a parquet from this folder. I can feel also other parts, but it's buggy, the portal, so I need to wait just right now, and after that I can feel the other parts. Actually, what I want to do is to say, hey, take all the IC/partition/ type clicks, year, month, date, star.parquet into a single file. So here, to tell this story, I can see, IC, partition, yes, type clicks, okay, year, wildcard, month, wildcard, and the wildcard. Dot parquet, let's preview the data. Okay, that's good. And since I promised you that if you organize the data set inside your data lake with that folder structure, with that segments, we can use those as a parameter. We can just say enable partition discovery, and this activity will push up the new columns over there with the inferred values from the URL. Okay. After that, okay, nice. Copy. I want to sync. Now, my concern is that I'm creating a new datasets for each part. In real world, you can just have one or two, and you can use parameters to reuse your connection, to use a dataset pointing to the same storage. But to be fast in this demonstration, I'm creating new stuff in each step. Okay, so I know that it's not optimal, but just to be fast. So this is another dataset that stays here. Few seconds more waiting. And now I want to tell this activity to put in a single file merged from the several files it finds into IC/ aggregates new folder. And here I can say type clicks.parquet. Oh, yeah, the casing. Okay. Good. Merge the files, and I can debug it. The debugger is my best friend in signups because it's really fast, and we can use it to test our activities. In this case, it takes really few seconds. I hope it's finishing. Okay. Amen. Yo. Please. Okay. Just a couple of hours and it's finished. Please. Usually it takes 10 seconds to perform a ticket like this. Okay, so let's see the preview. Okay, succeeded, good. It read about 33 files and it puts into one single file. Even in this parquet to parquet aggregation, we see the savings because of the thing I told you before. Okay, so with 4 megabytes, we have a 33 parquet that was really compressed and compared to the JSONs. Okay, we can see the results here in the aggregates folder. Okay, but now we want to scale up we want to perform something more scalable in terms of reuse of the code. So we have 3 types. So I want to aggregate all the 3 types. If we have 100 types of report, I want to do the same aggregation, but without writing 100 pipelines. Okay, so I change my pipeline, telling this. With this specific activity, I can read, like listing the blob storage, okay? So I can say, hey, again, data source in Parquet, pointing to the storage with this file path. Give me some seconds more. The portal has some bugs. It's something that you can discover by yourself. So you need to make some little workarounds. And here I say, hey, go to the partitioned folder. Good. And as an action, try to list the child items. I just put the relation just to debug it. Okay, not because I want really execute the second part, but just because with this relation and the breakpoint, it just executes my first activity without executing the second. If I don't make that connection, it started in parallel. Okay, so let's see okay. Good. Let's see the result. Not yet. Okay, so it listed all the 3 types it found dynamically in that folder. So we can use a for each. Excuse me for the space, but I want to ensure that the resolution is okay. Huh? Okay, so for each, and here we can say for each get metadata child items. Okay, so take the output from the previous activity, go into the child items array, and for each one, perform the copy data. So let's cut it and paste here. But there is a problem that this copy data is strictly related to this type. Okay, so I want to push this is as a parameter, okay? So I can say concat of this stuff, but this comes out from the loop, okay? Well, and I can use this item dot name. Why dot name? Because I was fasting while working, but the structure was the child items, an array of the couple name type. So I need to say item dot name. The same stays for the sync, because in this data set I'm hard coding the name of the files, and this is slightly different because I can just say here to use the incoming parameter from the loop, because the actual parameter should stay here, so inside the nested resource. In this case, I can use this trick to have a parameter. I can call it name, okay? And now this can be the file name. When I create a parameter in a data source, actually it will be reflected into the activity that is using the data source itself. Okay, so now I need to pass here the file name, and now here we have that as the parameter of the inner loop, the outer loop, sorry. So here I can say concat again, because now we want the item dot name and point parquet. Okay, let's go in the loop. Let's take out the breakpoints. Let's give a click of the debugger. And the good thing is that the for each by default is parallel. So we are using now three, because the report types are three processes, okay, but under the hood are three pools, okay, parallel for data copy. So we can see them here in action. They are copying in parallel. They can finish one before, as you see, and the other one after a few seconds. And the result is that we have, okay, they are arriving. Okay. Some seconds more. Okay, the third one. I don't know why it's so long, but the good thing is we can scale up to many parallel workers, okay? Just an advice, okay? Those are the DEUs, okay? Stands for Data Integration Unit, okay? Data Integration Unit is the thing that you pay for, okay? So, my suggestion is to go into the details of pricing to fine-tune the usage of this DIUs, because you can spend a lot if you don't understand how to optimize them correctly. Okay. In this case, since I want to write to a single file, I give you as a suggestion that 2 DIUs are enough. Okay, but keep it just as a suggestion. Okay, just to resemble when you use that technology in the future. Okay, so we have those three, and we consolidate our data with the data copy activity. We talk about the alternatives. So this data copy is very effective, no code, not low code, no code at all. And it's fast, but it's just an appender. Okay, so it can perform something like filtering, projection, like one column or another, changing the name, perform this data manipulation stuff. No, it's just an appender. Append files of different formats, well, of the same formats and same structure, okay, same schema. If I try to consolidate the 3 types in a single one, it will fail, okay? So I need to use data flows. Okay, that is fully featured. And if it's not enough, we can go to Spark pools. Okay, now let's consolidate all the 3 stuff together to produce what we can also call a gold layer, gold data set, with all the stuff aggregated to say, for instance, that no matter what the report type is, I just want for a single country all the cost. Okay. taken from all the reports, okay? This is the result we want to achieve. And we can go here and create a data flow in Parquet from this folder. This is a wizard, okay, but you can do it manually in a few minutes more. Okay, now I'm importing the schema. Another advice here, this is nice because it's read all the different files, and for instance I know that one has the country column and other type has the country code column, so the impression has country code and the clicks has country, no matter what. But if your data set has, if your folder in the data lake has millions of files, this is not going to investigate all the files, okay, but just the first several, but not all. So this can be just to start, but then you can overwrite your schema with your desired schema, okay? Now that I inferred the schema from that part, I want to take just two fields, country and cost, because I want that aggregation right now. So I keep out all this stuff, count, campaign, clicks, year, month, day, sellout, conversion, epoch. Okay, I have the country code in some report types that I want to transform into country, so to normalize different the types of reports. I take out creativity, impression, okay. Then I aggregate all the stuff by the column country, and what I am aggregating, the column cost with a simple expression that is sum of cost. Let's give a preview. And I can have a preview because before the session I started the debug session that it takes around 4 minutes to start because under the hood it's spin up a Spark cluster, okay? And it can be paused in every moment, okay, but just to be fast in this demonstration, I just warm up before. This is another bug. Sometimes it works, sometimes not. This is the sometimes not. Okay, and but to be sure that it's working, I want to sync the results into where? Into the relational database, because now we are aggregating stuff, so it doesn't matter anymore of the complexity of the stuff that we are reading, because the result is just a few rows, one for each country. So let's define an inline dataset of type SQL. SQL database. Let's create a new connection to this one. Yeah. In the database demos, I think. Okay, this one. With the managed identity that I previously configured, of course, to work. Let's see it. Okay, it's working. And now that I connected DB, I say, hey, use the advertise schema, and the table can be igloo aggregates. I specify to recreate table each time because it's a result table. I don't want to append it, update data, and it's so small that I can recreate it every time. And this is okay. This data flow can be put into, oh, let's delete all this stuff, and I can just call this data flow into my pipeline. Data flow. Okay. Let's debug it. So, which is the lesson learned with the data flow is that we can handle schema drifting between input data set. We can project just the columns that we want. We can aggregate. We can do a lot of stuff, and we are just touching the spot of this technology, okay? And the result, of course, I hope, is a table that is called igloo aggregates here with I hope all the countries. Yeah, all the countries. So the preview didn't work properly, but the actual result is okay. Good. But we change our mind several times in this world of data, because data grew up, because we had concerns in reading with the custom aggregations that can change over time, and it was so hard to maintain all the stuff related to the organizing properly the data lake. So we go downstream to the Spark pools and to the Spark tables and Delta tables. How many of you knows the concept of a Spark table or a Delta table? Okay, very good, a few, but it's really important. And now we are going deep into, no, not deep, but we are going to introduce those technology. So. Okay, we are here. Let's take the aggregates, yeah, no problem. Okay. I have, this one that is ready. Okay, better. Okay, which is the logic here? I'm reading from a source. In this case, the source is a Parquet file, but don't think about the input, because it doesn't make so much sense to read from a Parquet and write to a Spark table that is Parquet itself. Okay, but so just to be sure that you got the point, think about this as a load from external data set. Can be a SQL data set, can be a Parquet in this case, can be something else. Okay, the point that I want to put the finger on is this one. So I don't know if you see in the backstage. No, I can just increase here. Well, I think it's okay. It's okay. Okay, thank you, Peter. So in this case, I can write IglooConf plain table. Let's run this. And what is happening under the hood? That this Synapse instance, in conjunction with Spark, is writing a table inside an internal storage, and is writing it in the Parquet format. Okay, so again, we are talking about Parquet. Which is the lesson here? The lesson is, when you use a Spark table, first you need to use Spark, Python, .NET Spark, but it's better to use Python probably. But you don't see the resulting Parquet that you are generating. So there isn't so much tooling around Parquet in the world, and probably what my amazing team told me is that if there's no much support to read manually Parquet and convert them, probably because we don't do this manually so much, okay? Because we can handle them with a technology like Spark. What is performing this technology is creating in a special folder that is in the Synapse container, in the warehouse folder, a folder with the table name, with the Parquets that are the results of our process, aggregation, and so on. And interesting part, in the Synapse serverless pool, we have that table exposed as a, not really SQL, no, not yet, just wait a few seconds more. Okay, let's wait a few hours more. We have the concept of external table that we can query with SQL. Okay, so it's very similar to the pattern we used a few minutes before with select star from URL. Okay, so let's see it in action. No, not this one. This one. Okay, succeeded, so I'm expecting to see the table here. Good. With this kind of table, unfortunately, we can just say, okay, insert into. No, Okay, so you are completely off the DML part of SQL. You can perform your DML with Spark SQL. So you can change here the language. You can say Spark SQL and say, okay, so insert into EC plain table. Okay, values, well, the first one is date. Current timestamp. The second one is, I don't know, is country. Why? Account campaign. Let's make X. The cost 100, and the clicks, yeah. And then year, month, and day. Okay. This actually works. Under the hood, what's happening? That the Spark engine will create another parquet, okay, with this line. So if I make the select star from this table, where account equals to X. Of course, this select can be also made by the SQL engine, the SQL Server Management Studio. But we can't change the schema. We can't update a row. So if I try to update here, update this one, set cost 999, where account is X. It says me that, unfortunately, with external tables in the plain format, it's not possible, okay? Because, as I said, there are issues with the schema drifting when you deal with data lakes, okay? So if a parquet has 10 columns and I want to add a new one, it's a problem. If I want to change a row, since it's a column store format, think about the process. I should read the single specific parquet containing that row, read all the stuff in memory, update the row, and recompress all the stuff into columns. So it's something really almost impossible to achieve in a timely fashion, okay? But Databricks invented, or well, supported really well, the concept of delta table. Delta table, we can create a delta table just saying to PySpark that the format is delta, okay? And again, let's change the name. Yeah, sure. Vabbè. Vabbè is the Italian of come on. Okay. Okay. And let's take another cell here at the end. Okay, let's run all the stuff. The delta format is a special format of organizing the data lake, always with Parquet, but also with a special folder called delta logs that contains all the differential incremental operation, all the schema-related features that that are related to your data set. So if I create a delta table at time 0 and then I update the schema of the data or just a single row, a new parquet will be created with that row. And in this log, in this special log, will be put a information that you need to read that new row instead of the old row. And this is performed by the Spark engine. So this is succeeded. The update was succeeded, and the final select, in fact, has 99999. If we take a look to the, where is it? Okay. Here, in the warehouse, we have a new folder that is called Delta Table with few parquet. The first one is probably the first one. This one, that is the bigger one, yeah, is even the first one, is one created by the write, the initial write. I don't know why they are 3, okay, but the second and third is just the difference, the incremental represented by the update. So if I read inside it, I will find a row with the cost 100. And if I read this one, I found a row with the cost 999. But since there's the delta log here that describes all these kind of operations in a hierarchical way, the result is that we have now an external table, delta table, that is not getting the duplicates, okay, but just the good one with 999, okay. Instead, if I read, of course, by manually this data set with the serverless pool, even with the wildcard, of course, where account X. Sorry, now just a second. Yeah, but after it wrote it inside this data source. So I'm not pointing in the sourcing part, but into the destination part of the Spark table. And I don't know why it's giving me an error. No, probably thinking about it. Okay, and now we have 2 lines. It's small, but you can see 2 lines. So if I read directly the Parquet, of course, I have a duplicate. But since I'm passing through the Delta format, there's this engine that deals with the complexity, of course, I have the latest one. Good. So this was our journey. And we are now here in this part experimenting. So I'm not telling you this is the way, okay, but this is our way to scale up, our way to deal with the complexity that is continuously growing up in the last few years. And pay attention to some points. I call it stability of source. Your source can change. Okay, so your report can change from a date to another date. You can just ignore the updates, so everything would go seamlessly, of course. But if you want to embrace the changes, of course, probably you will cope with the data drifting. Okay, so data drifting can be a pain. Also, the updatability is another thing that I want to push to you, is we are in a specific, if you're lucky, as I said at the beginning of the session, if you're lucky, you can just have append-only data sets. Okay, so it's great. You can just say, so let's start from the source where last update or timestamp greater than the last one. Okay, the last one you come from. But unfortunately, and in the destination, you can just insert. At least you can add new columns in some scenarios. But if you need to append, if you need to update your data set, and in our case, unfortunately, it is the 99% of the cases. So one day it arrives the updated data of yesterday, of 1 week ago. You need to pay very, very, very much attention to that kind of issues. And with a delta table, you can use both Parquet, that is scalable, and also update sources. With the intermediate step that I showed to you when I organize directly the reports into the data lake, it's not so easy to update the rows, okay? You just need to locate in the specific part of the data lake the right report and then overwrite it as a single file. And then if I have a consolidation process in place, I need to reconsolidate all the stuff to produce the result. Well, that's all I wanted to show you, and if time permits, yes, it is. We have like 6 minutes for the questions. You're welcome.
If you have a question, please ask.
Yeah, so how do you handle changing the code kind of gradually? Let's say your pipeline changes, how do you push it to production? What's your process for that?
Oh, well, actually, the good answer can be a version of my pipelines and so on, but unfortunately, we didn't do that yet because we experiment much hassle while developing inside ADF or Synapse. So actually, we are just have multiple lines with experimentation, and we just push into the proper ones when we have the right result. But not because it's not possible or is not suitable, because we are not ready yet to have this kind of mature process around this data ops operations. Okay. Sorry to be so general.
Sorry, how are the data scientists accessing the data?
Sorry?
How the actual data scientists access the data?
Well, this is a challenge that we are probably solving in the sense that in our data platform scenario, we don't want that the data scientists access directly to the data lake, but to what we call the consumer endpoints. Okay, so think about the data platform split into the source-aligned data sets, so the data sets really similar to the form that they comes in the data platform, and the consumer-aligned data set. So after some joining, after some aggregation, after some enrichment from other data sets, so in a continuous loop, you can take three sources, join together, then take another source, enrich the data, make an aggregation, and this is what business wants to start with. Okay, so this is the consumer-aligned data set. So we want to expose just that result in where, since it's not our master data, our single point, single source of truth, because the single source of truth is the sourcing part, those are just copies. So the consumer-aligned data set are pipelines, okay, that produce copies of the data. And those copies have been accessed by the data scientist, in our case, through the data source feature of AML Studio, for instance, that abstracts the access to the blob with like a container, like a abstraction. Okay. Welcome.
A little bit related to the first one. Do you know if it's possible to set up the stuff inside Synapse with ARM templates or build, let's say, data flows?
No, it's not possible. We try to for backup purposes, but it's not possible. The short answer, for the audience, excuse me, we are recorded and I didn't reply the question for our audience. In this case, the question is possible to recreate all the stuff of the inside Synapse with ARM? My short reply is no, it's not possible. It's a mix between ARM just for the provisioning of the Synapse workspace itself and then Git for the resources inside Synapse.
Is there a big price difference if these three different choices?
Between what?
Is data copy and data flow?
Yeah, sure. Okay. Yeah, the question is there a big price difference between data copy and data flow? Yes. Well, in terms of the model, the entire model, okay? In the data copy activities, you pay 1 hour of DIU about €0.25 or dollar, I don't remember, okay? But as I said before, you should investigate into the actual usage of that DIUs. For instance, if you have a parallel copy of 100 partition to other 100 partition, you can have like 100 DUs probably something less, like 64. For the time, it's enough, okay? And this can raise up to hundreds and $1,000 spending to perform the operation in few seconds or few minutes. So you can probably decide not to go in parallel, but to go in sequentially to save some money if you have not the time constraint to perform your activity in a few minutes. And this is the first point with data copy. Data flow instead is built by the vCore hour of the underlying Spark pool that runs your workload. And that's a completely different point. It's not a $0.25. It depends. I don't remember at all. And depends of how many cores has your underlying pool that, just to remember, is started on demand. So it's not something that stays uptime all the time. Okay, so I don't know if I replied to you, but the pricing is very different. I can say one is more than the other one. For instance, at the beginning, for us, data flow was too expensive, but just because we didn't use it so well. Okay, now probably with the data flow that is Spark-based, we can optimize the cost instead the data copy activities. And with Spark pools, again, we can spend even less because we are really fine-tuning the operation and stay really compressed in time.
Excellent. Thank you, Roberto.
To you.
All right, and we will have 1 hour of lunchtime beginning now. See you, stream. all right, lovely people. I hope your tummies feel good and you had a nice lunch. And now we have 2 sessions before snack, and we will start with a serious matter, security. And we have a serious person to talk about that. And that's why I need to speak in monotone. Welcome, Karl.
Thank you, serious Sakke. All right, welcome from my side as well. Welcome to the stream. Welcome back to the meet space for all of us here. It's great to be back at physical events. Great to be back at IglooConf. It's a little bit warmer than I remember IglooConf being, but no complaints whatsoever. So for the next 60 minutes, whatever. Yes, Sakke was just telling me that I can just fill however long of a space between taking away from your small break before this session. So 60 minutes plus Q&A. Just kidding, including Q&A if those come up. I'm still going to be here for the hallway track in any case. So we're going to talk about security. We are going to talk about kind of a lessons learned, war stories type of session, similar to what Rick did, but a little bit more serious, I guess, based on how I was introduced here. And the first thing about security is that we, of course, have a lot of regulatory and compliance and personal identifiable information sharing related regulation. And apparently Clicker does work. So one thing I was asked to do was to steal my previous presenter's personal data.
Who asked you to do that?
I cannot name them because of PII reasons. So I don't know why I'm doing this. This was in the requirements, and I guess I need to position myself somehow like I'm like this. But there was your chance. All right. Good. Well, welcome again. To talk about security. Why am I talking to you about security is that this is what I'm doing. Someone actually pays me to talk about security and do some security related stuff. I'm working at a consultancy company called EPAM, a global consultancy serving Fortune 2000 customers, mainly enterprise customers, very highly regulated areas, medical device makers, financial sector customers, and so forth. And I've been doing security related stuff and cloud related stuff for a number of years now, and this is basically a collection of my war stories and rants regarding these topics. Great. So our agenda or the plan for the session really is that we are going to talk about my definitions of some of these topics. What is cloud security from my perspective? I'm also trying to keep this a little bit more agnostic, so it's not only Azure specific stuff, but of course every now and then there might be some Azure terminology that I might accidentally slip in as well. And then we are going to talk about how are organizations actually taking and how should the organizations actually take security within their cloud adoption journeys and within their information security programs and cyber defense programs. And I'm going to define something that I call a cloud security program and how it's done and how it maybe should be done instead. And then we are spending the last roughly half of the session on a little bit more technical topics. We are going to talk about cloud security architecture. We are going to map that into hopefully familiar terminology to you if you're familiar with cloud adoption frameworks, well-architected frameworks, and so forth. And then wrapping that up with some lessons learned, indeed. Great. Let's get started then. So first things first. When talking about cloud security, it's no longer a question, as I alluded in the panel earlier yesterday as well, it's no longer really a question about whether or not organizations will go to the cloud at all or ever. it's now a question that we happen to be in the cloud already. What do we do now? How do we secure this cloud thing that we accidentally stumbled upon? Apologies for the lags there. And basically, cloud really was kind of going through this test of scalability, elasticity with the pandemic. A lot of organizations needed to scale to support remote work. A lot of organizations needed to break up their existing security models and no longer just kind of be stuck in this analysis paralysis mode of waiting for some big change in cloud vendor side or big change in the regulatory space to take that leap. So we're already there. We need to figure out how to make this take back the technical debt that we incurred with this maybe 2 or 3 week jump during the first weeks of the pandemic, when everything was moved to the cloud, every network was opened, and now we kind of have to figure out where do we go from here. And where do we go? Well, we go towards something what I call cloud native security. And by cloud native, I don't mean Kubernetes, I don't mean containers, I don't mean anything to do with cloud native computing foundation. There is, of course, a little bit of term gap there, but basically I'm looking at something that feels a little bit more built for the cloud instead of something that's kind of bolted on top of the cloud. Is something that we used to do on security and that just shifted or lifted and shifted into that cloud environment. So what does it look like? It's basically looking something like this. It's very different from what we used to do. It's no longer based on buying some specific products, buying some from that same network vendor or firewall vendor that we used to buy for a number of years, maybe already. It's no longer just an implementation project, kind of fire and forget. It's not about outsourcing security to something as a service or something as a managed service. Hard to describe what is really the difference there, besides the buzzwords and adding more letters to those acronyms. And it's really something that requires you to acquire new skills. If you're coming from the security background, you need to really start to learn about cloud, not just map your existing data center tiering system into the cloud world or other type of approaches. You actually really need to understand how is the cloud built and what are your peers, what are the developers building on top of the cloud. And similarly, if you are coming from the cloud background and not the security background, you basically need to extend your remit into not just thinking about availability, features, cost, scale, but also security now. And it's really something that's built individually for each of the clouds, and that's the cloud native part. You really can't use something that's using the least common denominator across all of the clouds, maybe something that's a virtual appliance just stepped or bolted on into your virtual network. That doesn't cover the bulk of it when we are talking about impactful coverage for cloud native and cloud security. So it's really built into the cloud. It's not bolted on top of the cloud environments with something that's just basically, if you peel off the covers, you'll see that it was the janitor or it was still the old school on-premises networking component still. So regarding those skills and regarding those investments, there's basically this asymmetry of cloud security that I see in a lot of organizations, that they have these massive investments in this bigger claw. Thank you. Anatomy of crabs is always interesting. So in this bigger claw and very overpowered bigger claw, very asymmetrically overpowered claw, we have this investment into traditional security components like firewalls, like network sniffers, network flushers, all of these next generation or whichever generation firewalls and so forth. And I don't know if you even see, but there's this teeny tiny part, this other claw here, which is all about the cloud security. And this is something that might maybe come from the same vendor. Now this older vendor is also selling you something related to the cloud, and that's why you happen to be asked to use it. Or it can be something that's maybe is a completely new environment. You've heard that now that you are using containers, and you've heard that you need to do some container scanning, for example. There's this new set of tools and technologies and just stuff that we need to learn. And this is really the gap that we need to bridge. We really need to get this at least closer to each other. So how do we do that? So we really do need to understand again, if you're coming from the cloud world, this is something that you should already have seen, you should already have heard about this thing. It's on the very definition of public cloud platforms, hyperscale cloud platforms. It's a shared cloud responsibility matrix. From the security point of view, there is a bit of a difference, though, when we start to look at this in more detail. So if for some reason you happen to have come to IglooConf and you haven't seen this, a quick walkthrough. If you come from the on-premises side, there towards the right of, not your screen, but of your head, it's an interesting choice of terminology coming back to the physical conferences. So if you're coming from the on-premises side and moving towards the various abstraction layers or service models of the cloud, you're basically giving up the available security controls for you. You used to be able to control everything up from the physical side of things, including the physical networking part, including the physical security, of course, all the way from there up to actual physical servers, all the way from there, including the virtual machines, operating systems in those, middleware, and so forth and so forth. And when we go to the infrastructure as a service, we have a lot of those available, but not everything. And we need to rely on how has a specific cloud provider that we are using, for example, how has Azure built these services, and which part is actually just a generic description of this is what we aim to do, and which part is actually about something that's documentable or admissible to auditors or admissible to your internal auditors. So this is about finding things from documentation, from docs.microsoft.com, from Trust Center, from all of these different locations. But you have some controls available for you there. You have the least security built in. There's more responsibilities for you when you're working on the infrastructure as a side, and where you're moving towards platform as a service and functions as a service, containers as a service, etc., all the way up to the software as a service. You're getting more integrated security, but you have less controls available to you to change those. You just might need to be able to go with the flow. And that really means that when we start looking at some of these services in more detail, we start to understand that even though we might have thought about some of these services as being on the very managed side of things, having a lot of integrated security, and there not being a lot of operational responsibilities or other controls that are our responsibility, in fact, there might be actually quite a bit of things. Here's an example of something that quite often gets misunderstood or misinterpreted, the managed Kubernetes service, like AKS in Azure. It's managed in terms of someone else is actually downloading patches to your nodes. It's managed in terms of someone else is spinning these clusters up. You can do a lot of automation in there. You still need to reboot your nodes after those patches have been installed. You still need to do a lot of hardening. You still need to do a lot of monitoring. There's a lot of responsibilities that are up to you. There's several layers of networking, in fact, that are fully under your control. Egress control, ingress control, in and out of the cluster itself, actual role-based access control within the cluster, and so forth. So in terms of Kubernetes, basically we have the Kubernetes control plane environment like kubedns, API servers, we used to have dashboards, all of those that are handled by Microsoft. And then everything else, everything that's running on those Kubernetes namespaces that you see are your responsibility there. So I really, really recommend you look at, and we are coming back to this when we are talking about these lessons learned, I really recommend you kind of decompose your cloud services in terms of understanding what's available built in terms of security, what is your responsibility, and what can you even do about any of this. And then hopefully mapping that into your actual requirements regarding security. So now that we have the crab part away, we can talk about the cloud security programs. How do organizations start putting these various things together, and how maybe they should be doing that? So there is this balancing act regarding enterprise security overall, but enterprise cloud security specifically. On one hand, you have the options of tying the screws very, very loose, implementing a lot of restrictive controls in terms of identity and access management, like policies, like RBAC, taking away a lot of access, putting in place a lot of order remediation, and so forth, taking away the options for self-service. That's great for security, that's great for our auditors. That's not so great for our speed, our time to market, maybe our whole reasons for going for a cloud. If we actually have made a conscious decision of going for the cloud through building some sort of a cloud strategy, hopefully supported by the business, not just accidentally trying cloud out, chances are that you are doing that because you want to beat your competitors to the market when you are building new products. You maybe want some new innovation. You want to be able to use these new AI and machine learning tools that you cannot just do at all on the cloud or without the cloud, or the cost of doing that will be just so cost prohibitive. So you need to enable that part of the business, or you need to specifically enable that part of those developers who want to use these new fancy tools that you haven't had time to lock down yet. So that's the balancing act that you need to play. Because if you don't do that, of course, as any developer knows, cloud is just cloud. I just spin up a new subscription on my own credit card or even my whatever environment. I can do all of those things on my own. The shadow cloud approach is very easy for the developers to do, just for development and test, or just for staging, or just until we get the real stuff running. And you don't want to go there because then you really lose the control. The press doesn't care at all if and when something goes wrong and a developer accidentally opens up or does something wrong from a security perspective in an environment that's their own. If it stays or if it's associated to your company, then you need to deal with it in any case. Most organizations I see tend to overcompensate and balance one or the other. They might be kind of fully trying to embrace this federated, go do anything you want, we'll catch up, don't worry about it. And then they might come back again, and it might be this pendulum that's swinging back and forth about centralized control and fully decentralized kind of do what you wish. I would, of course, like the scales tipped a little bit more towards the security side from this perspective. But again, it's the balancing act. You don't want to tie these environments into so closely monitor or closely controlled environments that you limit innovation there or limit the speed to market. Kind of the classical example will be that any cloud service that your developers can use needs to go through internal security review And again, from a symmetry perspective, you might have maybe 100 developers in your organization and maybe 10 security people, or even less. So of course, the chances are that the security people are not aware of the cloud yet, so they will take a little bit more time. And even if they will be as up to speed regarding cloud as you, the developers, are, you will still need to catch up in the sheer volume of the ideas and the services that you will want to use. So perhaps you can shift left that security part as well by bringing developers the tools to understand how to secure this environment, even if there isn't a playbook or internal checklist for this specific service yet, what are the things that you can check in general and how to apply those in new environments. So the whole problem space regarding cloud security programs is that how do we kind of keep building cloud security policies, and by policies I don't necessarily mean Azure policies, I mean policies in terms of humans deciding that these are the rules how we play within our cloud, this environment. So how do we design these types of rules, these types of policies that are competitive, keep us competitive or get us into a competitive mode, and how do we also make that, that secure? So it's kind of a catch-up job as well. So from my perspective, this is as a consultant, I will come in. At that point, I will talk to the customer and an enterprise there. I will talk about a cloud security program being defined, being something that defines the processes, policies, and controls to secure the cloud environment. And usually what happens at that point is that basically this. So this is what happens when you look at this very strict definition of a cloud security program. It's quite acutely aware of how security is perceived, perhaps, by a lot of developers. It's not very competitive friendly. It's not very understandable in terms of, well, what type of an Azure service do I always need to go for premium, or what's the impact for me? So instead of defining this as we used to define this in the kind of world where security was that this kind of ivory tower of its own, or kind of a stamp of approval at the end of the product development cycle, I like to define this a little bit more user-friendly. But again, it's still jargon for a lot of people, but it's hopefully a step closer to the real world. So from my perspective, I don't really care about those formal definitions. I care that you understand as an organization what is the appetite for risk for you, how far are you expected to go. It's not, because security is not just black and white. We can invest infinite amounts of security dollars or security controls and still not get into the level that's needed. We need to understand what's enough and where to put those story points, for example. So we need to understand what is our risk appetite, understand it in terms of not just something that's in a nice piece of consultancy paper that's locked in the safe, and when auditors come, you will just tell them that this is the risk menu for us, but we need to circulate and get some awareness around that across our environment. And after that, we need to understand what sort of security controls are then appropriate. So, for example, if we need to keep network traffic keep all cloud traffic in our network, do we need to go for private link? Do we need to just make sure that there is an access control list defined for the platform as a service components that we are using? What's the appropriate control for us to use in these types of scenarios? You don't want to over-engineer it just because security told me so, but you need to understand what's the appropriate measure for these risks. So basically, this is about minimizing that asymmetry of the clause. And the way enterprises work quite often result into this kind of analysis paralysis that there's this lots of different committees, lots of different feedback loops, and again, lots of different policies that are impacting all of this before you actually get into the meat, which is, again, this controls piece here. So in here we have the actual policies, guidelines, policies, guidelines, and the actual security controls, which are some things that we actually apply in our cloud environment. It might be adding a firewall, it might be clicking on the TLS version enforcement, it might be actually redesigning your platform. There are different actual deliverables or different impacts of what is a control, but this is the actual piece that gets translated into a backlog. If you're a developer, this gets translated into a cost. If you're an operator, this gets translated into mitigating an established security threat from an unacceptable level into an acceptable level. So this might not be the right level of detail and level of analysis paralysis, but the heart is in the right place in this. The end result, the outcome is the security controls there. So once you know that eventually you will just need to have a reason to invest on identifying or applying some security controls, that kind of a program of different committees or projects or someone building development, someone doing risk assessment, all of that security program work going on. The outcome of that are those security controls. And those security controls then essentially affect your cloud environment. Essentially, they affect your cloud architecture. So this is the implementation part of that, a little bit more abstract part of that work. So cloud security architecture, from my perspective, kind of what it comes down to is basically a list of these controls. It's a collection of security controls for your cloud environment. And it doesn't have to be, depending if you are using multiple clouds, you can still reuse the same cloud security architecture. But again, the actual controls need to be cloud native. So you can say that you need to enforce TLS 1.2, for example. The actual security control is different when we are implementing that for Elastic Beanstalk versus if we are implementing that for Azure App Service, right? Eventually, it's about protecting the confidentiality, integrity, and availability of our assets, our data, our security, our components in that overall architecture, not just the security architecture. And again, it needs to be unique to your organization's risk appetite. So how does this look like? So if you work with these CAFs and WAFs and that sort of stuff, you may be familiar with the approach of having this secured cloud platform in the bottom. It might be one or more landing zones that you have in there. Eventually, that's just your cloud environment. It's an Azure Active Directory tenant that is tied into multiple Azure subscriptions. You might have multiple levels of abstractions and grouping in there. You might have management groups, you might have nested management groups, but eventually it's some sort of a secured cloud platform that you have on the bottom of all of this. And into this cloud platform, you are then basically dropping these cloud workloads. And cloud workloads are just a specific way of calling applications. They might be completely new, something custom that you're building, or they might be something that you are migrating from an existing environment. And usually this work is then split into having these centralized teams like the CISO organization working with these landing zones, working with this centralized platform, and then a little bit leaving the actual workload part a little bit disconnected. A little bit, again, we are having this potential for this asymmetry here. But how can we bridge these two worlds? in, for example, this CAF model is to use standardized templatized environments. So each workload actually consists of a number of standardized products, internal versions of the cloud services that you're using. So instead of each of the workload team, each of the application team building their own template, Bicep, ARM, Terraform, whatever, building their own infrastructure as code template for each of the services that they are using, and potentially needing to introduce that same security analysis each of the time they are taking into use of those products, you should look at centralizing those templates, having maybe a center of excellence type of team or some other way of building a set of standardized templates of your cloud services, and that's where you can actually include your security controls. So if you have a workload that uses an Azure App Service and I don't know, CosmosDB, for example, then instead of that team working at building those services from scratch, figuring out what should we do, and maybe only realizing some of those security controls, you should look at centralizing, especially the more obscure or the harder to implement or harder to find security controls, and building those into these infrastructure as code templates. And that's how we can make this program more scalable as well, and that's how we can actually support the part of the organization that once has that need for speed. And if we approach it like this, we can start to again shift left. And this is one example of that. So here I'm just using a tool called Chekhov, which is one of these template security scanning tools. You can run it in your CI/CD. So at that point, it will be called infrastructure as code, static application security testing. So infrastructure as code, SAST. Or if you can go even more left from the deployment perspective, and you can actually implement this. In the development workflow. So already at the time when you are building that template, or if you are using that template built by the centralized team, you can introduce some standardized security tests here. So this is just an example with Terraform, because that's what I happen to have in here. I'm building a virtual machine. It happens to be a Linux virtual machine, so it's giving me in my Visual Studio Code, because I have the Chekhov extension installed, it's giving me kind of intelligence regarding security that, hey, have you thought about, not implementing username and password in your Linux virtual machine, but maybe using SSH logging instead. Good security patterns and good security recommendations, but getting those out of that vault for auditors and kind of in the screens, in the face of the developers. And that's what this shifting left means. So that's for the products that combined make those into those workloads, into those applications. And a lot of the security controls that can be done centrally or have to be done centrally are then applied into that platform that is hosting those products. And in that platform layer, we can implement identity and access management, we can implement other types of security controls. I'm just going to run briefly some examples here on the IAM side. Usually this is very slow part, because you need to integrate with your organization's existing IAM processes. If you need to define a IAM product for each role-based access control assignment, or for each key vault role that you have, or even for each secret that you are storing in a key vault, that's going to generate a lot of activities, a lot of slowness in your cloud adoption journey. So you can think about maybe putting some self-service in place there, or you can think about automating some of those parts of creating those processes, instead of trying to catch up, trying to hire a little bit more IAM process people as well. And once you start doing that, you actually start to realize that there's not just the control plane, but there's actually the data plane side of things, and there's some in-cluster roles, and there's lots of granularity for identity and access management there that you do need to keep on working on. It's a continuous effort. And then kind of the third step of the maturity model or that evolution is then to think about the overall life cycle of those workloads, of that environment as well. So essentially, even if you hardened the crap out of your cloud environments, you've taken all write access away from your developers, from your subscriptions or from your environments, and you only limit your access to deploy resources using templates that are built securely and are scanned against security rules, and you are centralizing that to a CI/CD pipeline where you are making those deployments. You still are left with having a single place of potential failure. Now you are abstracting away instead of hardening and monitoring if your subscription role-based access or your control plane access is hardened against user access. Now you need to also check your CI/CD, and hopefully you only have one, but how can you know? So credential resharing is certainly an opportunity. And we only recently got access in Azure side, for example, of evaluating, adding some conditional access for these service principals. It was basically just a blank canvas. Anyone could have reused them, and a lot of organizations did, and a lot of malicious actors did, if you recall the Solorigate, for example. So basically it comes, again, from the process perspective, from the enterprise perspective. Either the IAM team needs to extend into understanding that it's not only about the product, if their mode of working is that they are spending 1 or 2 weeks or even 1 or 2 hours per each product that they need to build. For example, an SAP role for a specific user business functional role. Now they cannot scale that same model into the cloud because of those amount of those different roles and those entitlements. Remember that term when you look at some of those new branding changes from Microsoft, like that Entra and these other cloud identity related tools. So you need some sort of either reaching from the IAM side into a more scalable model, or building something that's hopefully not a shadow organization of that, but a cloud native mode of operating on that. And then another part that's in the platform side is this detection and monitoring. So this is basically two things. It's the traditional logging part, audit logging, making sure that our resources actually generate logs. A lot of Azure resources by default don't. This is an excellent piece that you can integrate into your products instead of for each developer trying to figure out for themselves what is the specific security log that I need to enable from this new service, because the name is always different. Instead of having to rework and reinvent the wheel on those, you can build that into that templatized product, and you can verify that centrally using Azure policies or other cloud security posture management tools that monitoring the platform level. Are your products doing what they are supposed to be doing? So you need to enforce those audit logs, and you need to decide where so you need to enforce the audit log emission. Your resources actually need to create those logs. Azure Web Application Firewall and Azure Key Vault notoriously do not create logs by default. At least for me, it's the first firewall that doesn't log that I've ever heard of. But there you go. Those are the things that you need to build into the product. And then you need to decide from a architectural perspective, where do you store those logs? Chances are that your team needs to have access to at least some part of the operational work in order to troubleshoot your front door or application gateway deployments. But you also need some sort of centralized logging place for your audit parts as well. And you need some sort of faster cycle to detect and respond to any security alerts, any security anomalies as well. So you need to store your logs and automatically enable create events and perhaps even incidents out of that, and basically create tickets for your security operations center team to mitigate or at least investigate those. So you need some sort of centralized logging architecture. Here's a very basic example. On the top, I have an application subscription, and on the bottom, I have another application subscription. They both have their own log analytics workspaces. So just a place where you can store all of your logs. That is, write once, read many type of storage. So it's great. You can run your custom queries in there. You can be the Jack Cousteau of your logging life. That's fantastic. And then you can also store from those same resources the logs in a separate location. There's a little bit of duplication. That's fine. There might be some cost impact, that's something that you need to decide and design together. But eventually, some sort of combination of this decentralized and centralized approach to logging architecture is what you'll most likely end up with. And it could be that instead of this being in Azure here, I don't know, this could be something else. And I can't really write at all, but that's good. I don't want to say that I'm talking about any specific vendors here. What I mean is that it doesn't have to be on the cloud. Did I just skip over a slide? Yes, I did. What I'm saying is that it doesn't have to be in the same cloud that you're working on. It can be somewhere else. And then the last part on the platform side is networking. It's a whole topic of its own. There's those private links. If you are using private links, it's basically egress cost for all of that traffic. So no longer traffic within the cloud is free because it's getting outside of your own tenant, or it's getting outside of that free plane of existence. You might not want to implement that every time, but even you do, chances are that it's hard to implement, it's hard to troubleshoot, there is networking, there is addressing, there's lots of different topics that you need to think about. So a very good thing to centralize again. And then you need to figure out how to connect your different subscriptions, maybe different regions, maybe different clouds together as well. In the Azure space, of course, if you are working with these sovereign clouds, maybe clouds from the US government, maybe clouds from China, those are in different network spaces, those are in different Azure AD tenants, and so forth. And then typically something that's part of the actual application design or the workload part, connecting the network planes of existence of the platform as a service side, infrastructure as a service side, and these various other as a service pieces of Azure. How do you connect your Power BI securely with your infrastructure as a service component, and how do you connect the same into your, let's say, Azure applications, Azure App Service web app, for example. A lot of network design, a lot of pricing impact, and so forth to think about. And then finally, something that a lot of us can do even on our own, we can add a web application firewall, even if you're using front door or an app gateway, it doesn't really matter. It's a good place where you can introduce security controls. It's something that you can tune on your own if you want to. If you want to have a lot of job security for yourself, use the built-in ones from the cloud provider. They're okay. Or you can go for a best-of-breed solution somewhere else, and you can also go for a managed service from somewhere else. Then you can actually bring in someone who has worked with or has even heard about, for example, Apache Mod Spark rules before and can tune them for you instead of you trying to troubleshoot. Why don't my health probes or why don't my application access get through my web application firewall there? Lots of options on that space. And then we move on to some of those lessons learned there as well. So identity and access management is really one of these pieces. I already talked about this quite a bit, but this is where I see a lot of organizations stabbing themselves, sometimes to death, really, because of this integrating not the technical integration. I can fairly, it's just a technical problem of integrating with your whatever IT service management tool you're using, not naming any names here, with your Azure Active Directory entitlement management. That's just a technical question. But implementing that part into your actual processes, where most chances are that if you are in a regulated environment that has spent a lot of time asymmetrically working on implementing network security and building a large IAM team with a lot of structured processes on onboarding new applications, chances are that changing that piece is going to take a long time. And if it's not done right, then I mentioned Solorigate earlier. This is what can happen when we introduce these kind of new cloud access types, such as managed identities or service principals. We need to understand what they are, and if we don't, we basically either overload the IAM organization altogether, or we end up basically in this shadow IT world within our existing tenant, where a same service principal is getting associated multiple different roles. It's getting, maybe even added multiple different credentials, and it's getting used to multiple different things. And then from a platform perspective, we don't know what is malicious, what is normal, and what is not. And that's when you can come in and take over an existing SSO, existing app registration that's built for something completely different, such as third-party application SSO. You can get your own credentials in, and you can start to elevate your access. You can start to move across that organization and find the weak spots, just like they did with Solorigate and those service principal reusable credentials. Now, on the cloud platform side, things are a little better now. Microsoft implemented in the UI limitations of how what's the maximum length of those credentials. But if you work with them, you might already know that it's only a UI change. The actual password or expiration or the credential expiration times can be still significantly high. So it's again still something that you need to work on. And this very much applies into these privileged roles. Usually we understand that owner and contributor are privileged roles, and that's fine when they are assigned to users. But when we are dealing with unmanaged roles and unmanaged identities, such as service principals, or federated accounts, or guest accounts, or shadow IT tenant accounts, or just temporary accounts, that's when it gets harder to monitor what is normal and what is not. Apologies for that. So one option is to build some self-service. You can build cloud account vending machines where you have those roles or where you have those service principals available as snackable sizes. It's something that you can go on and select in a self-service mode that I want this type of a credential. I need to be able to access, for example, these APIs with these types of roles. And instead of going through the same hoops that you maybe used to do earlier, kind of designing a business functional role and whatnot for that, you can just dynamically generate those. You can go through a verification if needed, and then deploy those to your users. So as a category of topics, if you want to learn a little bit more about that, kind of instead of IAC as code, infrastructure as code, it's now identity and access management as code, which is a bit of a topic of its own as well. You might have worked with Bicep or ARM templates or blueprints at one point where you'd also deploy the roles. Well, something similar you can also do with Azure in there as well, with native Azure roles as well. So besides identity and access management, another part that can go very wrong is the vulnerability management part. Again, a topic that you used to be doing in an enterprise already for ages. Chances are that this can be one of those asymmetric parts where you are spending already significant time, resources, and technology, but mapping that into the cloud world might not be as successful as you, or as easy as you might think, whatever your existing vendor for those vulnerability management tools says. You need to understand the scope. A lot of these services, if they are based on agents that need to be deployed into virtual machines, they can't have visibility into those other planes of networking existence without you actually connecting them. They don't have access to your platform as a service if they're deployed into infrastructure as a service and there's no network connectivity between them. Some of them are based on having access to the control plane of your environment. So basically you are granting a reader access to a third-party service who then reads everything that you have in the control plane, maybe reacts even based on events, such as from Azure Event Grid, and then alerts you or updates that inventory based on those changed events, and maybe even automatically mitigates some cloud control plane vulnerabilities. That's great, and that's where we can again, when we know that we deployed something secure, and over time we get an alert saying that now something has changed, we can build standardized ways of getting back into that secure state. If we actually have an understanding that what we are covering is actually everything that we are actually using, and that's not always easy to understand. And then there's, excuse me. And then there is containers. Very, very fun topic for vulnerability management, and a topic where you can really get into this signal noise problem quite fast. How do you know that when you scan your container on the deployment time, how do you know that the tons of CVEs that you are getting, that these are relevant? How do you know that you actually need, where do you focus on fixing those, and how do you know, are you actually even using those containers anymore if you are working with a vulnerability management solution that's, for example, scanning your container registry? You then need to map into, okay, this was the version of the container that's in my registry, there are some vulnerabilities, and then need to check through all of the places where you could run your containers, and then there are dozens, Kubernetes, ACI, app service, and so forth. You need to go check all of those at runtime. Am I actually using this container? So it's again more of an asset inventory question rather than a vulnerability scanning question. There are tons of free tools that you can use to scan for vulnerabilities for those containers. Docker scan, for example, it's just a Docker command that you can integrate as part of your CD. Fantastic, you get the results. You may or not, you can fix them, or you can choose to ignore them. That's fine, but you at least get coverage at the right space. And when you're specifically working with Kubernetes, you can have services like Kubescape to look at the runtime security, or use tools like Kube Audit or Falco to actually look at the security hardening guidelines and security of the actual cluster itself, not necessarily the workloads that you are deploying into them. And something that just sounds very cool, but it's actually a very basic set of guidelines. The NSA has actually, together with CISA, introduced the hardening guides for Kubernetes and hardening guides for containers. It's basic stuff as such, don't build your containers as root, that sort of stuff. But it's still something, from a project perspective. Usually, if I'm asking in an application security program, if I'm asking to implement security best practices or to meet compliance requirements, the answer from devs might not be the biggest hurrah as such. But if I'm telling them that, hey, now this is a fantastic project to implement NSA-grade security for your environment, that's usually achieved a little bit more enthusiastically. But again, a good free resource for you to look at. And then finally, we have the cloud solution and cloud service provider vulnerabilities themselves. We had ChaosDB, we had break information, we had just recently we had the Synapse vulnerability as well. This is something that as the cloud reaches more maturity, we get more usage of cloud, and with the more usage of cloud, we get more eyes looking at the cloud environment, looking at also accidentally breaking it, but also maliciously or intentionally trying to break these clouds as well. So breaking the isolation models of these multi-tenant services is quite scary. But how can we mitigate this? It's again, when we are mapping this back into the shared responsibility model, for example, with ChaosDB, if you already knew what you were doing and you understood what was your responsibility, chances are that it was just a matter of inventory management checking, are we actually doing what we were supposed to be doing, of that we thought we were doing across all of our Cosmos accounts, and if yes, then we are good. Same with the Omigod, the VM agent that's deployed into all of the VMs in Azure, including Kubernetes. There's a massive vulnerability there as well. But if you understood that there is what are all of these agents installed into my VMs for me, what is the shared responsibility at that middleware part of my VMs, and if you understood that if it's a virtual net, if it's an infrastructure as a service, I'm responsible for protecting the network part as well, you were good. You could, if you managed to verify that by having an up-to-date inventory management system, after that you could just wait until the new patches were released and then implement those. Or in Cosmos's case, just do nothing and just wait, because it's managed service, just wait until that gets fixed by the CSP. But in order to have that confidence when these things are at the level of they are hitting the news, chances are that someone calls your CISO or someone calls your CTO asking, are we vulnerable? What can we do about it? Or prove to me that we aren't vulnerable. You need to have understood that shared responsibility first, and you need to be able to implement those as part of your operational responsibilities of those incidents as well. I even had a slide on that, sorry. So when we are talking about the overall applications and overall supply chain, it's not just the applications that we are building ourselves. We might have dependencies. Those containers might have been built on top of some, however minimized, but still dependencies on images that are built by someone else. We need to understand who has built them, what are their responsibilities. Are we paying for a provider to get these hardened images, or are we using just something generically built by someone? And have we verified that these are actually provided, these images are from sources where they think they are? There have been cases where just by using a similar name for popular dependencies as a publisher, someone has been maliciously able to propagate their own images and their own dependencies instead of the public source, just by doing a little bit of better search engine optimization there. And then there's the impact of, if you're a US organization, you need to be able to start building these software bills of materials. There was an executive order recently on that. Basically, nothing really that you need to, as such, do yourself if you're not a US company, but you will see basically from a lot of these SAST tools and a lot of these software composition analysis tools, you'll start to see something called BOM or SPOM, software bill of materials, or just bill of materials. It's just another report that's going to be built and generated that maps the dependencies that you're using and also the open source risks that you are using. And open source risks might mean that if it's a project that only has a small number of maintainers, or if it's a project that has had CVEs available for a long time and not been fixed, a lot of these kind of sanity checks against these dependencies, that open source risk is part of that software bill of materials, that another report that you're about to do. So, just to summarize, go cloud native, which is not Kubernetes, despite the amazing illustration in there. Think about cloud native in terms of cloud native security that is individual for each of those clouds, but still meets your risk appetite and is able to give you the appropriate controls, native controls for each of those risks. Embrace and maybe fix this cloud security asymmetry in terms of trying to get that crab into a kind of more balanced set of tools, not just focus on the programs, the teams, the technologies that you used before, but build in those new capabilities. And then focus on coverage of all of your inventory so that when you spill your milk or when something hits the fan or when you have those cloud misconfigurations, you know that you are covering everything, all subscriptions, all resource types, and you know what are the appropriate resources to fix them. And then there's a bunch of tools that you can Bing with Google and look out for a little bit more details there as well. That's it. Thank you.
All right, guys, go and grab a cup of coffee, go to bathroom, take a smoke, but then come back immediately, since in 5 minutes Michaël will start with his show on Dapr.
Dapr.
She slashed our
Are there a lot of people out there? Some, but not much. Okay, I think they're gonna come in a few minutes. So let's begin. It's time to go. I will butcher your name now, man. Michaël!
Close enough. Thank you. So let's start with a raise of hands. Who has used Dapr already? Okay, great. So at least some people know it, and most people will get an introduction. I'm happy to provide that one for you. My name is Michaël Hompus. I'm an IT architect for InfoSport in the Netherlands. And happy to be in my first year as an MVP. Thanks. And when Dapr came out, of course, new tools, so we started using it. Because, new tools are always great. So every new project you start with, the latest, you don't know what it does, but yeah, you see it all around on the internet, so it should be good. But I thought, okay, which problem are we trying to solve? Let's first take a step back and really think about how can I apply this for my situation? Is it even a good solution? So let's go to the beginning of a project. This new seed you're planting because you have a nice idea or you have a new customer, new project. You need input. Input in what you're going to be building. So you have to make choices, and a lot of choices. As first, you have a customer. And if it's your own hobby project, maybe you're your own customer. But if you're in a corporation, it might be a customer that's going to pay for your services. That customer has expectations. Maybe you're part of an organization. Here again, maybe a small team, maybe multinational. And that organization will also put requirements and constraints on your possibilities, how you execute your project. And then if you're part of a team, that team might also want to make choices or give input for those choices. They might have certain experiences. If you have a team full with Java developers, it might not be the best choice to start a Rust project. Maybe they will want to do something cool because, well, they were Java developers, but then again, do you want to take the cost of retraining and maybe failing because you don't know or don't have the experience? It can also be that your team has assumptions. We have a new project, therefore we are going to do the latest and greatest and not use an old version or an LTS version of some product or service. And all these kinds of input introduce complexity. You have two types of complexity. You have essential complexity and you have accidental complexity. So for example, business value, well, quite essential to include it in your project. And maybe we need some state. The developer thinks, I need state. I have SQL Server, or I need Oracle, or maybe I need Hibernate now, or Entity Core. I'm going to introduce libraries, NuGet packages, NPM, Maven, just by requiring something with state. Microservices might be an essential complexity. It might be very reasonable that you want to use microservices because of the type of project or platform you are trying to develop. So it can be put in the essential complexity column. When we start using microservices, we also want them to be available if something crashes, that another version of the application is started up. So now we need orchestration. And we just heard from Karl, then you need Kubernetes, because that's the way to do it. Then we have to deploy things. So how are we going to deploy the containers or other services we want to use? How are we going to get our configuration in that environment? Are those services talking directly to each other, using REST calls? Or maybe we are going to use a service bus. We want to be disconnected. We want to be reliable. Maybe we want to use the pub-sub architecture. And then, of course, if something goes wrong, maybe we need something with observability. But they're all accidental complexity. They don't add essential value to the product we are delivering. Maybe you read something about service meshes, because yeah, also cool and new and necessary. So when does it stop adding complexity and we didn't even start building code yet? And we need to deploy somewhere. And that can be cloud. And the cloud can be on-premise. Yep. So no code yet, but a lot of choices to make. And then, of course, reality happens. Because maybe there are changes. A customer wants something different. You deliver your first version, it's totally not what was expected. They forgot to mention some non-functional requirements. Yeah, it also has to perform. Oh, didn't know that. Or maybe you have the golden egg, the golden goose of all products, and everybody wants it. But yeah, you build it for Azure, and this customer really wants to host it in AWS. How are you going to solve that? Or you do it with Microsoft SQL Server, and this customer just bought some Oracle licenses. So please, put another database underneath it. Or what if you want to do it at the same time? Can you support that? How much time will it cost you? How much code will it cost you to support multiple different layouts, different vendors, different environments? Can you handle these changes? So the question is, can you reduce the amount of code and complexity in your application in another way? Well, like I said, or what I want to say is, of course, a great quote needs to be in your session. So I'm standing on the shoulders of giants that came before me. Thank you. No, another quote. An architect should make as few decisions as possible and deferring the rest until later in the life cycle. This is an old quote from Ruud Malan and Dana Briedemeyer, which names I also probably butchered now. So how can we postpone those choices until we have more information and can make a better judgment? So now we're going to tie it back to Dapr. Can Dapr help with this? And if we can do it, can we then reduce the accidental complexity? So, Dapr, what is it all about? Dapr stands for Distributed Application Runtime. And if you read the website, it says an event-driven, portable runtime for building microservices on cloud and edge. And if you read edge, that's just because people don't know how to write on premises. So they call it edge now. Dapr is thought of with a certain amount of goals. First one is use the best practices for in building blocks. So if you have building blocks, they should be easy to use. They should adhere to the best practices, things like that. It should be capable of working with any language or framework, even SharePoint. It should be consistent, portable, and use open APIs. So not embrace and extinguish, no, open for everybody. So it should adopt standards. It should be extendable using pluggable components. It should be platform agnostic, so cloud and edge, and community-driven. So if you look at Dapr, there's a call every month where everybody can join, just talk about it. It will be published on YouTube. It's on GitHub. You can contribute. You can respond to issues. And that is also vendor neutral. So yes, it was born in the kitchens of Microsoft, but it's open for everybody, and they don't exclude you based on using different technology, languages, or clouds, etc. So how do they achieve this? Well, first, Dapr contains those building blocks. I will go into them in a bit. But those building blocks are exposed using HTTP. And also, if you want to have better performance, gRPC. And what's the benefit of exposing things using HTTP? Almost any language that's around these days can, in some form or matter, send some data over an HTTP port or receive it on that way. So that already allows basically any language to interact with Dapr. On the other side, underneath Dapr, basically any cloud or edge can be used. So yes, you can use Kubernetes, and with that already use a lot of clouds, but you also can just run it on-premise on your laptop in different ways. Who is already familiar with sidecars? Oh, quite a few people. Probably all heard it in the context of Kubernetes, probably already, but sidecars are not a pattern that's only limited to Kubernetes. When I have two applications and they want to communicate with each other, I could do that directly, but I could also put two sidecars between next to each application. And that's the Dapr API. And then those sidecars are the ones responsible to build a secure connection and execute functionality. When I then want to use something like a state store or do something like publish and subscribe, my application will not be doing that on its own. My application will be communicating to my sidecar, and the sidecar will be doing the communication with whatever service I use for pub, sub, or state. On the other hand, there are bindings, and input and output to those bindings are also flowing through those sidecars. So no dependencies in my code. If you look at the Dapr API, basically any building block that's around has its own endpoint. So for example, I want to call another service from my service, I use the invoke endpoint. And then Dapr is responsible to find the other party and make sure my data gets to that location. The same for state. For publish and subscribe, not very surprising, we have two endpoints, one for publish, one for subscribe. We have bindings, we have actors for the actor model. We have observability. Well, yeah, observing traffic doesn't need an endpoint. We have secrets. And if you want to know anything about the state of your Dapr environment, there's also a metadata endpoint. So let's look at an example. Service invocation. I have a front end and I have a cart. So basically an e-shop. I have my two sidecars. My front end wants to do something. So it goes to the endpoint of Dapr, says I want to invoke the cart service. Where this cart service is running, how to connect to it, using gRPC, HTTP, pigeons. Front end doesn't know. But it gives a payload and a method name, and that information is shipped to the sidecar. That sidecar knows where to find the cart sidecar. So that communication goes to that sidecar, and that sidecar then knows how to communicate with the corresponding cart service. If the cart service responds, then the data will also flow back. Another building block is state management. This is not relational database state. It's really key value pair state. the same thing can happen. As an application, I want to store something. So, for example, I want to post a list of data, a list of key value pairs, and I give a store name. And based on my configuration, this might be Cosmos or Redis or whatever state store is configured. If I then, with the same state store and the key I used to store the data, execute a get, I get the data back that was stored previously. But I promise you, we are going to look at some code. So who develops with Python? Nobody? Oh, okay. Then somebody can read my code. Node.js developers in the room? Yeah, also some. Are there Go developers at present? .NET? Oh, Lord. I'm going to cover all those languages today, so let's first look at an Hello World application. And of course, we start with Node, just to get it out of the way. It's not that complex. We need to know how to communicate with our Dapr sidecar. So a sidecar, just like you might know from Kubernetes, where you can have multiple containers in a pod, you just communicate to localhost, to whatever port my sidecar will be running on. And in this case, 3500 is the default port number. I have a state, which is called state store. And basically, I declare some endpoints. A get endpoint to get an order, and a post endpoint to store an order. And basically, those endpoints are in my application. But they will call the order endpoint on my state endpoint for Dapr, and also to retrieve it with some code in the same way. Here's better. I'm also not very familiar with reading this kind of code. So let's see how this works. I hope it's big enough. Not sure why. So I start Dapr now locally on my machine. And I give my application a name. I give my application a port. And I give my Dapr side container a port. And then I basically say, run my Node application. This will give me a lot of debugging information, but my application is now running. So let's test this. First, I will just invoke my application, the Node application, and I say, I want to execute the order method. Doesn't return anything, which is not surprising because I didn't store anything in my state store. So let's post something. Okay, I get a 200, okay, nothing went wrong. So let's see what's now in my state store. I have something in my state. This was a very impressive demo, I know. So maybe we can do something more with this. And it's also, let's prove, I didn't do anything hard-coded. I get something different back. So let's get another application, other language. This is about the same in Python, but in this case, my Python application will invoke the new order command and not doing a manual execution on the command line. And basically, it will just be a never-ending loop posting order IDs. So I basically do the same. In this case, I don't need to define all the ports because I'm not receiving any network traffic. And now you see on the left side my Node application is receiving them. So I can stop this for a bit, and then if I look again, the current state, it's 13. So what state store am I now using? Because in my code, I talk with Dapr, and I can store data and can retrieve data, but it has to be somewhere. And in this case, it's in a Redis environment. So I have a local Redis instance, and if I now refresh, I here see the current version of my data in the store. So this is looking directly in Redis. So if I now clear my whole Redis environment, I do a get, it's empty again. So even though I have two languages, only basic HTTP request response, but the applications can reach each other and they can store data in Redis without actually having any dependencies on either application or any Redis library or packages dependencies. And still everything works in a couple of lines of code. So what you saw is basically this application. First, I manually did a get and a post against the Dapr runtime. That was interacting with my application. And when I did something with state store, the Dapr runtime was also interacting with Redis. And then my second demo, I used Python. And the Python application invoked via its sidecar the other Dapr instance. And the rest of the application worked in the same way. So I used Redis locally now. And every time I give this presentation, the sheet gets fuller and fuller. There are quite some state stores supported at the moment. And basically every new version of Dapr, this list is growing. So I can use state stores in Google Cloud, in Amazon, in Azure, of course, Oracle Cloud, and also a lot of generic services that you can install on premises or on your local machine, wherever you want. And there are differences between different state stores. So that's where the check marks are for and the red crosses. Basically, CRUD operations you can do with every state store. That's the bare minimum. Some state stores also allow you to do transactional things like fill, everything succeeds or fill. Some can support e-tags for also doing smart things with caching and updates. You can do time to live, and the amount of features that are supported grows every time there's a new release. But I won't be going into the more advanced topics on this. So this was running locally on my machine, nothing other than my local infrastructure involved. The next step is looking at Kubernetes. If we install Dapr in Kubernetes, we get 4 pods or 4 operators installed. And every time I install an application in that Kubernetes cluster, and I indicate this is a Dapr application, Dapr should be enabled, the sidecar injector operator will make sure that Dapr will be installed alongside my application. So I have a container, I deploy it, and then the Dapr runtime will make sure a container is connected to my application. And therefore, I can use all the components I want that are configured. So, more code. For this, I will be using an application, a sample you can find on GitHub, that uses 4 different programming languages because, yeah, we can. So first, some .NET. To do subtraction in a calculator, we have a complete .NET application with an endpoint. And if I post 2 operands, they will be subtracted. This is our business value. We also have a Go application. So if you're not familiar with Go, it's quite easy to read, I think, ish. I think there's too much code in the view for what the application is doing, because it's doing additions, and basically it adds two numbers. Not sure why they need so much code for adding two numbers. I'm not here to judge. Also a node application where I do some divisions. So here the division is mentioned. I have a Python application which does multiplication. So 4 different languages, but every language contains one single business value, but only the business value. In all those 4 cases, they don't know anything about each other. They don't know anything about their environment. They only can execute what they are built for. Then I have a YAML file, because we love YAML, and basically registering a service with a front end. And just to highlight, because I set the Dapr IO/enable to true, then the operator knows I have to inject a sidecar. So let's deploy this. I have a folder with those YAML files. Currently my application is created. It's already running, so that's great. Let's see, it's really running, yes. So for example, 9 times 8 is 0, that's weird. Oh, it's not performing very well. Just checking if my pods are actually all running. Yep, everything is running. Let's try this again. Yep. Okay, times 9 is 27, plus 2, 29, minus 4. Okay, took some warming up. Almost looks like a real application. So my calculator is working. Yoo-hoo! And now, let's use the right one. If we look at our containers, so I have now 5 containers running, every language and the front end in its own container. And if I look in the library, also see, and this might be a little bit harder to see, but this is a sidecar for the add app, the sidecar for the multiply app, the sidecar for the front end. So every container for every application I've deployed, there's also now a sidecar running in Kubernetes. And let's see at the logs of all these languages. So I did add a couple of numbers. I did some multiplications, 1 subtraction, and 1 division. So every application in its own scope has done what it is meant to do. And by the magic of the invoke service, I could invoke everything. But it's also running in Kubernetes. So if I need scaling or other functionalities why I would want to use Kubernetes, that's all covered. So, and of course, one benefit is also I can delete them quite easily. So what I just did was deploy my set of resources. I got 5 containers. Every container got its sidecar. Those 2 were connected to each other, communicating with each other. If I press some buttons in the front end and I would give it an operation, the front end would reach out to one of those different containers or applications, depending on which button I pressed. And maybe you didn't see it, but if I press F5, the number was still available because it was stored in a Redis cache, and in this case, a Redis cache deployed inside Kubernetes. Another nice feature are bindings. If you're familiar with Azure Functions, those are also known have bindings to bind to storage accounts or PubSub or whatever you want. It's quite similar for Dapr. So if I want to have some external application that triggers functionality in my application, I use an input binding. And it can be Twitter, it can be Event Hubs or Kafka, or whichever binding is supported. And every time an external trigger event has happened, the sidecar will execute an endpoint in my application. The other way around, if something happens in my application and I want to trigger something in the outside world, I can post to my binding with a payload, and depending on how it's configured, some external source can be triggered, and that payload will be provided. So there are even more bindings than state stores. Also here in Azure, Alibaba Cloud, in ZB, Amazon, Google, and of course a lot of on-premise, or wherever you want to run them. You can use them as input, sometimes as output, and sometimes you can use it both for input and output bindings. Publish subscribe is also one of those interesting things. I already shown you invoke, but when you're using invoke, you have a one-to-one connection, and they have to be both alive to work. PubSub allows you to do something disconnected, so maybe your other service is not available, but you can still deliver the payload, and in another moment that might be consumed. But you can also do one-to-many consumption, so you publish it only once, and multiple sources can consume. And also here, with publish and subscribe, the sidecar can publish to whatever bus you want, and also subscribe to topics, so your application is notified when something is published. Up until now, I did a lot of REST calls. Well, at least the code did, but I had to write basically or a web server to host and consume, or I had to write REST posts to deliver. Of course, this can be done much easier by using SDKs for the language you want. And there are quite some client SDKs already. So the most used are .NET, Python, Java, and JavaScript. And recently, for example, PHP has also been added as a client SDK. And for some parts, you have server extensions. And if you want to use the actor model, there are also SDKs for that available, but not for every language. So for my last demo, I will use the Dapr traffic control scenario. This is created by my colleague Edwin van Wijk. And I'm not sure if you are familiar with speed cameras here in Finland, but in the Netherlands it's a nice income for the government by basically putting 2 cameras above a highway. And if you drive between the distance of those 2 cameras in a certain fashion, you might get a nice reminder that you were there with your car. And you have contributed to the government, or at least they want you to. So for this demo, we will have cameras, we will have cars. We have a Department of Vehicle Registration, because, well, the camera only sees a license plate, so doesn't know who's driving it or owning the car, so we need to do some lookup. And of course, we have some government agency want to send you a bill, and depending on how fast you drove, maybe even invite you to hand over your license. And we are going to do this all with Dapr. Of course, I don't have a whole highway rig with me, so I will use some visual simulation. We will have a traffic control service with 2 endpoints. We will have a fine collection service with an endpoint. And we'll have a vehicle registration service with an endpoint. And that's the premise. So first we start with the simulation. Those will be just MQTT messages using Mosquito. We'll use traffic control service with bindings. We will then store some state in Redis. We will publish some events to PubSub. The fine collection service will listen to PubSub. We'll use a binding to send emails. I'm not going to show it in much detail, but we have a license key, which is in a secret store. And we will have a service invocation. And we will use a combination of these in code. So first, let's look at the code. In this case, I have a .NET application. And basically, I only need one package reference, dapr.asp.NET Core. Because this example has been extended, yet you can also use the actor model as a state store. Those dependencies are in, but if you would only use or not use actors, you basically only need the Dapr ASP.NET Core package. So the traffic control service is only listening to the bindings of MQTT messages. So if you look at the program CS, we configure the Dapr client, but basically all the rest, except for the actor registration, is just regular C# code, in this case for .NET 6, so no namespace declaration. We want to store some data, for example, which cars have passed the entry camera, so we want to store something in the state store. So for that we need the Dapr client, and we want to save a vehicle. We say Dapr client save state and the type. And when we want to retrieve something, we say Dapr client get state. And basically we get a typed object back. So this is just an easier way than writing down HTTP commands, which you're still fine to do, but I think this is more pleasant. So some MQTT binding, how does that look? So a piece of YAML configuration, very important, the name of the binding, so that's entry-cam, that will be used in our application. The binding is of type MQTT. Then in the metadata we just configure things that are necessary for this binding. In this case, would be quite convenient if you point to an MQTT bus. And then in this case also a certain topic. So every time the Dapr sidecar, this Dapr sidecar will listen to this MQTT endpoint topic, and every time a message appears, it will notify my application using the entry-cam name. So in my application, I just have an HTTP endpoint. So this is just a regular controller, nothing special, just normal dependency injection, and an HTTP endpoint. And every time my HTTP endpoint will be called, it will be with one of the messages coming from the camera. And in this case, I only, at the entry cam, will store some state. And at the exit cam, I also get the Dapr client injected. I can read the state, basically the data stored when entering. There will be some calculation. Did I violate some laws? And if I did, there will be a speeding violation created, which then will be, via the Dapr client, be published as a PubSub. So the name of my PubSub is PubSub, not very inspirational. There I have a topic called speeding violations, and my data is published. So still, basically my application only contains my business logic. I need to get some data, I need to store some data, I need to do some calculation, and if a calculation triggers some limit, then I will post a message. In the fine collection service, because we are going to use PubSub, as a consumer, we need to configure a little bit more, still the Dapr client, and in this case, we will register an endpoint to do an invoke, and we will say, after add controllers, add Dapr. That will make sure that any PubSub configuration will be automatically have the right bindings. So in the controller, I now can have a route, an HTTP post, but I can also describe that anytime on the PubSub endpoint or dependency, if there's a speeding violation, trigger this endpoint. This will be set up automatically by the SDK, so that saves me a lot of time. And in this case, I will create, after requesting the vehicle information via invocation, I create an email and then we'll use a binding to send that email. Well, let's see if we can get that to work. We need some services, some Dapr applications. I need a mailbox. For that I use MailDev. And then I will need some simulation. For some reason all my screens went to different locations, which is very annoying. So also here I will be running locally, no Kubernetes involved. I will run the traffic control service at a certain port, just like I shown before, and in this case I just supply some paths where to find the configuration files. But basically in the end I say .NET run. That's all. So it gives me a lot of metadata. I will do the same for the vehicle registration service, and I will do the same for the fine collection service. So now I have 3 Dapr applications running. One is waiting for bindings coming from MQTT, and the other one is waiting for PubSub, and the other one is waiting for invocation. And nothing is happening because there are no cars driving over the road. So let's fix that. So we have some cars, and yesterday you built a nice application indicating when people are arriving in the country that require a lot of Mintu. So we see also some trucks with Mintu arriving now for Mark. And while they are driving, I'm going to pause the application for a bit. Let's look at the first application. Every time a car passes the entry lane, you see it's getting triggered. In the middle, you see when somebody is speeding, so it will trigger a speeding violation. And on the bottom, there are the requests about which person is connected to which license plate. And on the right top, I have my application, and the government is getting rich because I constantly get emails that somebody at a certain time with a certain car drove too fast, and in this case can hand over the license to the prosecutor. So what is happening is that I use local Redis, and that's nice. Ask Rick, local Redis is nice. I'm now trying to get Rick crying. I didn't start yet. Because I have my local Redis Explorer, I see my queue, and I see all that data that was stored in Redis, locally. But now is the time to come to the conclusion, maybe Redis locally on my machine, I can start developing. I know I need some state, I need a PubSub, but I also want to start developing. Well, I've written my code. I don't know where I'm going to deploy. I don't know if it will be Azure. I don't know if it's going out to Alibaba Cloud, wherever, I don't know. In this case, we also have nothing in Azure, but let's say we want to move our Redis to Azure. We are going to use pub/sub, and instead of using localhost, I will use dapr-traffic.redis.cache.windows.net, and of course I need a password, which I don't show on screen, sorry for you. And this was my change. Now I'm using Redis in Azure. And of course I need to prove that. So I start applications again. No exceptions. I let the cars drive by again. I get some complaints because in the cars leaving the segment at the moment in the state store didn't have the entry data, so that should be figured out in a while. Already see some payments coming in. Okay. And let's look at our local host. Yes, it contains still all the traffic state, but not the queue. That's now in Azure. So I've moved to Azure by just changing 2 lines in my configuration. My code didn't need dependency on Azure-specific NuGet packages or NPM packages or whatever, only changing configuration. So my state is still in Redis locally. So let's move to, well, let's make Mark happy even more. After the Min2 truckloads, we're going to CosmosDB. Because why not? So here I have a Cosmos with vehicle data and documents, but it's completely empty. Nothing here. In this case, I need to change my state store. So no longer using Redis, I switch to CosmosDB. I disable my Redis configuration, and I need to configure where my CosmosDB is running, and of course a database key and a collection to store. And again, this was my change. Changing configuration in runtime doesn't work. I need to restart the application for that. So my application is running again. Cars are driving by. Yes, and everything is working again. I get paid again. So now we look in Azure. We refresh, and we see that all the data is now stored in CosmosDB. Again, the application is completely disconnected from my dependencies, only configuration-based. How long was your upgrade, Rick, to Redis in the cloud? It took me 2 seconds. So I've covered service invocation, state management, pub and sub, resource bindings and triggers. I didn't cover actors, distributed tracing and secrets. Actors, if you're familiar with the actor model, also just an endpoint where you can post, and the Dapr placement service will find the right location where your actor is stored and post data or retrieve data. Distributed tracing, all the traffic will use Open Census. So you can plug in App Insights, but any other open standard supporting tool will work. Secret management, you can use Kubernetes secrets if you want, but you can also use Azure Key Vault or Google Key Management. Basically, you just have to say, this is the name of my secret, and your application has access to it. Also very interesting is recently we had the introduction of Azure Container Apps. And I shown you how if you deploy to Kubernetes, you have an operator that will inject a Dapr container as a sidecar for your application. Basically, Azure is capable of doing that as well. If you set that Dapr enabled flag on your Azure Container App, it will also just inject a sidecar. And you can use Dapr inside Azure Container Apps, which is probably a little bit cheaper than just running a complete Kubernetes cluster for just a simple application. There are some small limitations, and they're really small, but they are documented well. And I think most of the time they will not be an issue. They're quite niche. But you can find it more on the docs. So I'm going to judge Dapr from my point of view. What are the benefits? What are the pros? I think I reduced quite an amount of code. I only had to write basically the business logic of my application. Maybe stupid business logic, if it's an adder and a divider, but it is only that logic. So if somebody has to read my application, they don't have to make a distinction between this is infrastructure code, this is about how you deal with this bug in Redis or this quirk in another dependency. Therefore, it also removes a lot of accidental complexity. You don't have those dependencies on dependencies on dependencies. Like upgrading one package, but you can't because that other package that's depending on that package cannot go to that version, and nobody recognizes that situation. Well, probably only me. So no dependency update hell. And you can really start building, focusing on building your solution. So what code do I need and not which dependencies am I going to use? You have to choose the type of dependency. I want to use state, I want to use pub/sub, but that's it. And the interesting part is you can vary those set of dependencies even per deployment. You can do one in Azure with only Azure services. You can do one in AWS with only AWS services. And it's quite portable. It's all container-based. You can run it locally. You can run it in Azure PaaS services. And you can also run it in Kubernetes and run Kubernetes almost everywhere. But there are also, of course, cons. With abstraction, you get the lowest denominator. So if you use Kafka as a pub/sub bus, you can use pub and you can use sub, and that's about it. And Kafka can do a lot more for you, but it's not available because the common denominator is that Kafka streaming is not available in Azure Service Bus or some other way around. If you use some dependency, or you want to use some dependency where the binding is not yet created, well, it would be great if you would contribute to the community, or you have to be patient and hope that somebody in the community will build it for you. But the list is long, but there are also a lot of dependencies not yet in this list. There are some hidden constraints. If I use state store and I use, for example, Redis as a backing store, and I put in, let's say, 64K of data in my field, it works perfectly. Then I switch to Azure Table Storage as a backing store. That doesn't fit. So there are hidden limitations. The interface is the lowest common denominator, but there are still technical details that might be a problem for you. And of course, Dapr is no silver bullet. This is only interesting if you want to build microservices, and not every solution is the right way to work, to use microservices as the solution. So really also try not to fix everything with a hammer, or if you have a hammer, not everything is a nail. Try to stick to where it's designed for. Some of the references I've used, of course, Dapr.io is the basic website, docs.dapr.io, all the documentation. I used on GitHub the quick starts, the samples, and of course also the traffic scenario I showed. You can use that as well. There is an ebook written by my colleagues and freely available, posted on Microsoft, docs.microsoft.com, focused on .NET development. And with that, I want to thank you.
Thank you. And we will get back from 22. So we have 22 minutes to have a snack. let's get some sugar in the engine. So yeah, I was 2 minutes late. That's my bad. That's my bad. And that means that Glenn has 2 minutes less. So I feel very bad about this, dude. I hope you can speak quicker or sleep less, or I don't know, man.
Speak loud, but not quicker.
Oh, go louder then. If that's the only option, do it, man. And here we have with random stuff. How do you... Glenn?
Yeah, awesome. Great. So we live in a world today where reality is that data is being constantly generated. So Forbes estimated that, in fact, every day there's around 2.5 quintillion bytes of data being generated. That's a 2.5 with 30 zeros behind it. So by the time we end Igloo and the start, there will be 5 quintillion bytes of data generated throughout the universe. And of course, this doesn't help. So like there's data all over the place. And this is a pretty good example, like the data that is being generated and data that is being used, 80% of that data is coming in unstructured formats. So think of PDFs, images, videos, audio files, and so on. So it is estimated that within businesses, within enterprises, so 80% of their data comes into an unstructured format. So as a result, it costs time and money, and then internal decision can become less informed because, yeah, people need to analyze that data, extract information out of that, and so on. So data information really has the possibility to become a burden, or you can make it something that, an asset out of it so that you can use it throughout. So, and this is what we are going to try to talk about today on how to extract necessary information from unstructured data. So my name is Glenn. I work at Azure Belgium. As Michaël already mentioned, we do like 100% Azure, I guess. And we have experts all over the place. So that's where we are. So the scenario today is based on a real-life scenario. So it is a data platform for the logistics, and their aim is to be the data platform reference globally. But if you're a bit familiar with the logistics, they kind of have like old ways of transferring data or sharing information with each other, like PDFs and emails. Again, like I mentioned, they have EDI files, they have scans of documents, like papers for the trucks, they come like in scans of pictures. So it's really an issue there on how to extract the necessary information there. So we're based, the demos today will be based on that scenario. To make life more easier for you and to not load you up with all the logistics issues, I've decided to download a set of movie data, images, some metadata about movies, like the title, the release year, the amount of money it costs to make, and so on. And for each of those movies, necessary images of that. So what we will be doing today is there will be a data producer, so a guy who creates data. What he will do is upload images in blob storage and upload the metadata of that movie into CosmosDB. So what will happen then is we will trigger event grid and use the blob created event, and that event will be used to tell cognitive services, hey, cognitive services, trigger your re-indexing and do OCR classification of the images that are in blob storage. So once we have extracted that data, we will enrich our CosmosDB document with that data in order to be able to have like one big document with all the necessary information. And what we will do is then present that on the website. And maybe it's a good idea to immediately show what our end result will be. And I want to apologize for my front-end skills, but at least I tried in this case, right? So what we will do is we will search. We will search for aliens, then we will get aliens back, which is good, right? Then we do like something like Monsters, Monsters University, Monsters Inc. Pretty good, but then it becomes a bit trickier. So what we will do is, and this is, cognitive search allows us to do like more semantic search. So if we do like movie with monsters and aliens, and my suggestion gave it away. So what it will do then, it will start to do like more semantic search on top of my data. So we have Monsters University, the Muppets, kind of monsters. So Superman is an alien, I guess. And then we have a lot of movies that probably have something to do with monsters and aliens. Dumb and Dumber, yeah. Yes. So back to the slides. Good. So what we will learn today is we will learn about data enrichment and indexing, how cognitive search is working. We will talk a bit on CosmosDB, a little bit, because Mark covered that yesterday, but we will do something fun. So take your cell phones. It will be super fun, I guess. Let's hope so. And then we will talk about cognitive search and how you use the API to query the data. So data enrichment and indexing. For people, we're in this part where we upload the data, do OCR classification, and then do the indexing of cognitive search. You've seen the slide yesterday from Zachary. And in this talk, we're going to cover the portion here on the left-hand side for you. We will cover the part where we talk about cognitive services, cognitive search, and so on. So what is cognitive services? So cognitive services is a set of APIs created by Microsoft and made available for you. And it allows you to do certain things on top of data. It allows you to do text analysis. There's a great API for speech that does translation, speech recognition, and so on. There's the whole image classification, image recognition, video analysis, and so on, which is the Vision API, and then the decision, which is giving you anomaly detection, and so on. So those are a set of APIs made available for you. So what has Microsoft done? They took those set of APIs and they create a thing called Azure Applied AI Services. And the Azure AI applied services, this is a mouthful, allows you to do, they wrapped around, they grouped some APIs and they allowing you to do stuff like form recognizer, bot services, and cognitive search is one of them. And cognitive search is a service that groups a couple of these APIs together. You, as a developer, can choose to either work directly with the APIs or contact or work with the Azure AI services to work with the packaged product. So today we're going to use cognitive search. And cognitive search is a platform as a service offering that allows you to do semantic search, keyword search, and so on. But what it basically does, it is making search intelligent. So if we look at traditional search or traditional search within application, you can or you have ingested data, And then you, as a developer, start writing queries on top of that data. But if you want to do like more, harder searches, it becomes really difficult to create your queries on top of that. And this is where the more AI-powered search comes into play. So we have our data ingestion, and then we have a thing running on top of that that starts enriching the data. And then basically what you can do is do a more semantic search on top of that data, where you really extract all the information you need. So in our case, in the case of our movies, we could have written an API or a website that was probably better than mine, but we could have created a website that searches for movies and aliens only on the metadata. But then I think you would not get that deep result from that. So what cognitive search is doing is actually what is called knowledge mining. So it takes the image and then runs an AI service on top of that, extracting all the information from that image. It does recognition of celebrities. It finds some items within that image, and so on. So you will see that all happening, hopefully, during the demo. So cognitive search has a couple of core components. So first of all, there's the data sources. So it allows you to connect to certain data sources. It allows you to connect to blob storage, to CosmosDB, and so on. And then there's the indexer. The indexer is just a service that is taking a look at your data store, grabbing the recent changes of that, and running that intelligent services on top of that. So an indexer is just a timer. You can run it once, you can run it every couple of minutes, you can run it daily, basically as you wish. And then there's the index. And the index is really the key of your cognitive search. It allows you to, as you will see in the demo, it will give you a complete index of all the documents or all the images that are within your data source. And it will apply some things on top of that. There's a couple of features that you need to enable, and I will also show you that and go into details on that during the demo. But these are important to take into account and to know what you want to do with your data. So if you want to sort on a particular field, you make it sortable. If you want to filter with OData style querying, you put that filterable value over there. And so based on those settings, you will start creating that index. So if we take a closer look at cognitive search, again, we have our developer who is ingesting or putting data into the data store that we're working with. And then there's a couple of things going on. So what will happen, it will kick off a sort of process, and it will start doing extraction of the fields and extraction of the data. What you can do then is potentially use an AI enrichment pipeline to call cognitive skills like OCR classification and so on. You can even use third-party enrichers, and all that information then will come back to your index and will be made available for you to query. So this is like the whole API, the AI enrichment pipeline, and it basically ends up with your index and make your data available. So let's jump to the demo. So as already mentioned, we first of all have a blob container with a couple of movies in there. So let's take one. If we take one here, you will see that, oh, Madagascar, nice. So these images are here. I know the quality isn't that great, but cognitive search can work with it anyway. So then we have cognitive search available. And if we take a look here, we have a thing called data sources. And in our case, we have a movies blob. And this is just a connection to my blob storage account. As an ingestion point for my data. Then, as already mentioned, we have an indexer. And you can see here that if I click it open, you can see some of the settings. So this indexer is running at a custom interval of 60 minutes, but you can configure it as you wish. You can configure to run it once, and so on and so on. But the real magic is happening here within your index itself. So if we look at our Azure Blob index, you could, and just give a shout if this is not clearly visible. So this is our index, and this is our main entry point for the application that we will start using. So as you can see here, cognitive search, what it did is it created a document within this index, and it contains all kinds of metadata related to my image within my storage account. But what it also did is it extracted some additional information. In our case, it has a location dinosaur, which is pretty weird as a location, but I believe cognitive search anyway. So, but what it also can do is it can extract celebrities, it can select other entities, and so on. So what we will do here now is I will run I will not show that website again, I promise. I will run a data seed, and what that data seed will do is I will add 6 new movies to my storage account and add the metadata of that movie to CosmosDB. So what will happen if you remember the demo setup? So cognitive search will do the entire OCR classification. Once it's done with that, we will take that OCR information and add it on top of our CosmosDB document in order to have like the full information available within CosmosDB. So let's see what this gives. So hello movies, this is a start. So we've inserted like 6 blockbusters. So we have Avatar, I Am Legend, The Avengers, Wolf of Wall Street, and so on. And as you can see, I've also uploaded images to blob storage. So if we would go to blob now, let's go to blob storage to actually prove they're there. This is the most exciting part of the demo. Oh, no, that's modified. Ooh, that was stress. They're there. So that's one thing that went okay. So now jump to cognitive services, Azure Search, sorry. And let us take a look at our indexer. So, and as you can see here, we have our Azure Blob indexer ran a few seconds ago, and as you can see here, the documents that are succeeded were 6. So 6 documents have been added to our index, and OCR information should have been extracted from that. So let's go to our index then. Here. And if all goes well, I should be able to do like, just type the name of the file. I think it was this, right? Let's do the Avengers. And as you can see here, the file or the information is already available within our index. So if we take a look here, as you can see, there has been I will just move here so you can see it. So data have been extracted from it. So it's just the metadata of my storage. But as you can see, what it also did is extract people information. So it was able to identify Robert Scarlett, Jackson Marvel from the people. So, and there's also some key phrases that it has detected. And what it also did was add some image tags. So based on how the image looked or what was inside the image, it added some tags over there. And then it also added some entities and so on. And all that based on just on the image that was within the storage account, which I can show you. So this one, if I can open this. Open file. So based on the image. So on this, so with just uploading the code, without just writing any code, uploading the image, it started recognizing a lot of things going on within this image. So, and just to show you what happened behind the scenes, or what happened with CosmosDB, is if we go to CosmosDB and we open our movies, we can do a thing like, should use snippets like Stacy, that's smarter. I also cannot type. It's demo, I guess. You can see here that the data is there. And we've enriched, no, let's do the Avengers again. Let's see, that's 300. So here we've just added additional data in our CosmosDB document just to make it available within our document for searching. So, and that seamlessly brings us to our next topic, which is CosmosDB. Now the exciting part starts. So if we're still following, we're here, and I should move that box up. So we're in the CosmosDB area. So, and as Mark yesterday said, so CosmosDB is non-relational by design. It is schemaless and really designed for scale-out. So in order not to repeat things that Mark said yesterday, or not to say wrong things while Mark is in the room, I'm suggesting that maybe let's do a little pop quiz. And I know quizzes on Friday, nobody likes them, but I hope you're a bit enthusiastic about this. I would like you to take your phone, scan this QR code. I'm seeing a lot of phones, awesome. Or go to menti.com and use this code. So I will give you like 30 seconds, stand here awkwardly. So there will be 2 questions there. Some easy questions, I guess. Let's see. If all goes well, I should see the results popping up here. Okay, great. We have 32 people. Awesome. Great, great, great. So I believe Mark will be happy that a lot of people paid attention. So CosmosDB indeed supports all the models that were mentioned here. It supports key value, it supports graphs, and so on. So the next, ready for the next question, or? Yes? Ooh, wow. Was that the question? Yeah, good one. Next. This actually works. I'm super excited. Great. Next one. So when designing a CosmosDB application, what is the most important concept to distribute your data effectively across into CosmosDB? I know. And Mark just came in, so he can probably validate the answer for me. So what's the most important concept to distribute your data effectively in CosmosDB? It's the partition key. That would be another question. What? All right. Thanks for joining. Awesome. So that was it. So 2 questions. That's not that bad. So indeed, like when you're partitioning, as Mark said, you're basically optimizing for both read and write. So it's and it becomes more critical at scale. And so let's skip a couple of these information. But I wanted to say that, yeah, it's really all about that partition key. So it's really important to get that correctly. In our case, in our movies, yes, this one, as we are doing I believe the data set was a top 15 movies of each release year. Release year was a pretty good option to as a partition key, as you have pretty stable items and distribution over there. If you would have chosen something like genre, and surprisingly, most popular things or genres within movies are action movies. There are some sci-fi movies there, but apparently nobody likes westerns anymore. So an action or genre would be like a bad partition key. So, and I think Mark already covered that yesterday. It's important to think about collocation of your entities just to optimize and minimize your query scope. So it's better to like store your whole document so that you can get all of your data in one go and you can serve it to the application that it's needed. Also think about your indexes and sorting and so on. If you need to run more complex queries, then Azure Cognitive Search comes into play. It's again allowing you to do that more semantic search on top of that data within CosmosDB. Important part here again, as Mark mentioned yesterday, storage is much cheaper than compute. So don't be afraid to duplicate your data and make it, optimize for reads and writes depending on what you need. So there's a couple of things that we need to know if we use CosmosDB together with Cognitive Search. There's a couple of important things that you need to be aware of. The first thing is the thing called the high watermark. So as already said, there's an indexer running on top of that data. So every time you configure it, so once a couple of minutes, it goes and take a look at your data source and see if there are any changes within that. So this is the default query that Cognitive Search uses to get that data. What it does, it takes a look at the _TS, so the timestamp, and it compares it with the @high watermark, and that's just an internal timestamp of the system the last time it indexed your data. So basically, every document that will match this query will end up again within your index. So it's basically just like a detection policy on that data, just to add it to your data or not. Another thing is deletion of the data. So you probably saw when I add documents into my index, that those documents, not if you like delete it in your original data source, automatically these changes don't automatically come back into your index. So the data has been added to your index, and they don't automatically synchronize that deletion, or they don't automatically detect that deletion unless you add like the _is_deleted true to your document. So you basically need to implement some kind of soft delete within your document in order to allow Cognitive Search to detect the changes that is happening within your CosmosDB documents. So if you need to do that, just add the _is_delete and use that soft delete method to track those changes. So let's jump back to the Azure portal and do a demo on CosmosDB. So what I will do is I will run through the process of connecting your data set, creating an index and an indexer in order to index our data from CosmosDB. But before let's do that later. So first of all, what we can do is start importing our data. So there's a pretty nice wizard if you use the portal. Of course, this is all supported with bicep files and ARM templates. So, but in order not to bore you with me writing bicep, it would be a stupid demo anyway. I will just click it together within the portal. So let's connect to CosmosDB. Give that a name. Choose a connection. Let's do this movie. Should find myself a database. And we can choose this collection. As you can see here, this query, I will open this up. So this is the query that is used from CosmosDB to get your data into Cognitive Search. And here again, this high watermark is important because that will be your reference point for when your indexer is running. So here you can change this query if you want. So I have a select star now, but you can choose to select only certain fields. You can do all the things that you want, as long as you respect or you include that comparison with that timestamp in order to get all the result that you need within that. So next within this wizard, you can add cognitive skills if you want. So what it does for you, it detects the schema automatically. If you want to add cognitive skills or cognitive services, you can add this here within that wizard. You can choose to add enrichment, and as I show you for my blobs, you can choose that he starts extracting people names, key phrases, languages, and so on. Because we already did that, we used another process to start enriching that data. We will skip this part. Next part, or the most important part here is, here you need to start defining your index. And as already said, here you can choose what fields will be retrievable, what fields will be where you will be able to sort on, what fields will be searchable, and so on. So be aware that some of these settings are unable to change once that index is created. So for the ease of the demo, I will just select them all because that's easy, right? So next part is you create the index or the indexer. Create the indexer. And we will say that just run it once. So while this is creating and running, I will show you one of the other indexes I have. So CosmosDB. You can take a look at the fields here. So, and as you can see within this screen, I can start changing some information. So I could change the retrievable part, but I cannot change filterable, searchable, and so on. So these things are unable to change once that index is created. Let's just discard the changes. Go back to the index. Let's see if it has ran. So as you can see, it's indexed our 401 documents, and now the data is available from within our index. So it didn't refresh, but I can assume that that data is available here. So like you can see here, again, so we've indexed our CosmosDB database, and this allows us to query CosmosDB in a more semantic way using cognitive search. So before we go to the last part, there's a thing I want to show you is the JFK files. I don't know if anybody already saw that. So this is an example of, this is a showcase of cognitive search where Microsoft took all the documents that were released regarding the JFK case. So all these documents were made publicly available. And what has Microsoft done? They let cognitive search do its thing with it. And this is like a pretty nice use case of that. So all the documents related to that case, you can now query if you want. So let's search for Mint. Mint2 will be difficult. Let's search for Mint first. So here, as you can see, you will see those information. I see minor, I see Mint. That was great. So again, this all cognitive search is running on all those documents, and the index has been created. You see here that there's certain tags made available. Cognitive search automatically tagged all these documents to group them together to make some sort of grouping that would make sense. I don't know if there's something like Igloo available. This is probably finished for Igloo. Sounds correct, right? I thought so. So this is a pretty nice website to showcase the capabilities of cognitive search and how they can index their entire documents without doing a lot of work. So back to the slides. So, cognitive search querying. So, I also have a quiz for that. No, that was a joke. I will stop soon, so don't worry. So, we're in our scenario here at this part where our data consumer, we've created the index, and now our data consumer, we want to create our search engine website where the data is made available. So cognitive search querying, as already mentioned, the scope for a search is always the index. So as a developer, you will be talking to that index and running queries towards that index. Again, I already showed this image, showed it during the demo. It's important for you to think about what will you query, on what fields will you sort, and so on and so on, in order just to, not to recreate your index. However, that indexing is done quite fast, so it's not a big of a hassle. But important, just think about it. So cognitive search, what is allowed? It allows you to do full text search. It allows you to even do like a geospatial search. It gives you a certain scoring. So if you're running a query on top of that, you get results back. And then cognitive search will give you a scoring on that result, so you know how close you are with the things that you want to do. So how does this work? There's a SDK available, and what you need is you need an indexing client, and you just give that you give it your URI, you give it your credentials, and then you can start creating a search client. So the API also have a lot of things available. As already said, these come back into the configuration that you do from within your index. So if you want to filter on certain fields, you want to do order by and so on. So it's important to take those into account. Once you've done all the settings, once you've created the options that you want, you can just run the search async with your search text, and then you're basically good to go. So cognitive search offers different options to query stuff. So there's the free text search, there's the count, you can do a select, you can order by, you can do filter, and so on. But I think it's just more easier to show it than just show code on a slide. So let's jump back to here. What I will do, I will not show the website. Somebody doesn't like my session, started crying. Sorry for that. It's okay. I will. So I already showed you like the free text search. So movies with monsters and aliens. That should work. So we have Monsters University, Monsters Inc., and so on. Interview with a Vampire. I don't know what monster is that about, but okay. And as already said, what you can do is you can start doing stuff like add a count to that. And count equals true, I guess. So what the count equals true will do is it will give you a count back of all the results that are within your query. So this allows you to do some stuff on top of that, display that on your website, so in order that you can give that user a full experience. What you can also do is do a selection of that. Imagine that we only want to select the title. So this will, again, return a result, but our result will only contain the title. So, of course, you can make that bigger, select a couple of fields that you want, but that option is available. So that's just the OData query. And maybe just to emphasize, you can see here that it adds a search score. And based on that, cognitive search is telling you how confident it is with the result. So what you can also do is like do filtering, like and you can say like, I want that the ImageDB rating is greater than 80. And then it will return those only the movies with a rating that's bigger than 80. So 81 is bigger than 80. That's good. And you can also do things like order by and so on. And this allows you to really do like really great stuff while querying that data. I think I already showed the .NET implementation. So this demo, including the pretty awesome website, is available on my GitHub account. So you can go there and see the implementation of the .NET SDK and potentially grab the website for your production use. So what did we learn today? So we've talked about data enrichment and classification, and where CosmosDB is, or cognitive services, is a set of APIs that are made available for you. And we've talked about how those AI services allow you to do OCR classification on top of that data. We've talked about CosmosDB, not that much as Mark yesterday, but we had fun during a quiz. And the thing I want to help you remind there is that the partition key is super important. And the key of making sure that your data is tracked for deletion is working with the soft delete, and the add high watermark will make sure that your data is being tracked as it goes along. And then we've talked a bit on the querying. So we showed the possibilities like filtering, selecting, ordering by, and so on. So that leaves me some room for questions. If not, thank you for joining. Thank you for being here.
I propose that we take a 10-minute break, and that gives Alan time to set up his music box. And then you guys come back 15 to, and then you can ask Glenn questions if you have some from him personally.
Good.
All right, 10-minute break, 15 to, back. All right, guys. We've saved, well, I don't want to say the best to last, but still, it's going to be a bomb. I don't know what it's like, but I've seen Alan's talks during the years, and they always leave me breathless, so I hope I don't cause any pressure, man. So, welcome to IglooConf, and let's have a great shout out to Alan. Welcome.
Excellent, and thank you to everybody who's been involved with this event, putting this event together. I don't know if I've been to every IglooConf. I've certainly been to quite a lot of them, and it's always been one of the best experiences of the year, one of the best conferences of the year in terms of the location, the audience, the presenters, and everything. It's always been really good, and it's great to be back here after a couple of years of sitting at home in a small box room doing presentations in different locations, but never really leaving my house. So a bit about the session. I'm going to be talking about neural networks. I'm going to be talking about basically starting out with what a neuron is, and then getting into image classification, custom vision, and rounding off looking at generative AI. Some of the things like DALL-E 2 and GPT-3 and Pix-to-Pix, those types of ways that you can actually generate stuff. That is not me dancing. It looks like me dancing, but the images are actually generated by a neural network based on the poses of Bruno Mars. So it's actually Bruno Mars movements, but that's AI generated. And hopefully you'll get an understanding of how that works by the end of the session. So there's an obligatory photo that I think somebody's got to take a picture of. Thumbs up when it's done. Okay. Excellent, thank you. So a bit about myself, Alan Smith. I work in Stockholm, just over the water, and I work at a company called Active Solution. We develop solutions for companies based on Microsoft Azure technologies, or mostly based on Microsoft Azure technologies. We're always looking for what's going to be the next big thing. We took a very early adoption of Microsoft Azure and persuaded many of our customers to start looking and considering using cloud computing. We're now focusing on Microsoft's AI offering, and we see, as you've seen in the previous session, there's great stuff that we can do with AI on the Microsoft platform, and also beyond the Microsoft platform, taking other frameworks and being able to run them within Azure ML and train models and so on. I was kind of thinking, AI, you can take a very serious theory-based approach with lots of, PowerPoint slides and formulas, or we can have a cool, fun session with lots of demos. So I kind of think we're going to be taking the red pill. It's last thing on a Friday, so we can have some fun. So this popped up on my YouTube feed a couple of years ago. And it just really impressed me about how they can basically create this type of AI. I can actually drop to the YouTube video, and what they're doing is they're basically starting with a professional dancer, and they're basically sampling the pose from a professional dancer. So that's the source subject, who is a professional dancer. You then have a target subject that you can actually perform the movement mapping to. And what they're doing is they're basically detecting the pose of the professional dancer. Initially, I thought this was done using a Kinect sensor. However, there's actually a neural network called OpenPose, where you can basically send it a video or photos, and it basically detects pose within the actual photo and gives you out the actual positions, which can then be converted to an image. So the detected pose from the professional dancer is basically mapped to the source subject. So the source subject is going to theoretically, copy the moves of the professional dancer. And it really blew me away, sort of how they can, create this type of AI. And I thought, this is what people are doing at UC Berkeley. There's no way that I could do something like that. It's got to involve lots of data science and a real deep understanding of neural networks. However, their code is available on GitHub. You can download it. If you have a sufficiently large GPU, and you need quite a big one, you can actually get it running and train your own models. So I'm going to go through some of those. This is my favorite one they've done with it, with a ballet dancer. You can see that on both of those source subjects, they're capturing even the reflections behind the dancer are being captured. So how do we get there from knowing nothing about neural networks? We can start to think about, what a neural network is. And probably the simplest thing we can do in machine learning is something called linear regression. We've got this in Excel. We can, put our sales figures on Excel. We get a bunch of points on the graph, and we can just say, okay, let's draw a line that's going to be an approximation of that. And the way that we can find the optimal line is basically by moving the line around and calculating the minimum amount of loss. Those purple arrows are kind of representing the loss that we've got within that particular algorithm. And that's what's basically done within a single neuron. If we have a single input and a single output, we've got two parameters that we can specify on that neuron. The first one is the weight, and the second one is the bias. So if we take the input and multiply it by the weight, and then we add on the bias, that's going to give us the result, which is basically y equals mx plus c. It's the formula for a straight line. So that can basically do a linear regression with basically one neuron in a neural network. So to show how that works, I'm actually using PyTorch, and I've built a neural network, and it's doing apartment price prediction using linear regression. So if we just zoom in on the code, should be able to find the actual network. So this is the network that I have created in PyTorch. So I'm specifying it's only got one layer and it's only got one neuron. And that's basically the simplest network we can run. What I'm doing is I'm training it on apartment data. So what I'm feeding in is the price of an apartment and the area of an apartment in square meters. First thing we do is normalize the data, because neural networks don't like really big numbers. They typically like to work with numbers around about +1 to -1. And then we're able to train the model. So it takes a few seconds just to train that on the GPU. And you can see the actual results there of the training loss and the validation loss. I kind of should have stopped after about 25 epochs. You can see that the validation loss is increasing, and I'm overfitting quite a bit. But this is basically now got a trained model to predict the price of apartments. So if my apartment is 50 square meters, it's saying it's going to cost 3.2 million krona, about 300,000 euros. If it's 150 square meters, it's giving that prediction of 8.2 million krona. Interestingly, it's not just a price per square meter. If I put in a price of 0, 671,000 krona. So it is basically a constant and then just basically adding on something per square meter to that particular price. That's what the model found was being the best fit. So that's basically the simplest thing we can do with neural networks. Another way of representing data, how does it deal with the street name? The street name is also going to affect the price. You can't put words into a neural network, you have to convert them into numbers. So they have this thing called one-hot encoding, where you give the value of the street that this apartment is on, the value of 1. Everything else has a value of 0. And feeding that into a neural network, the weights can be trained to say that, well, an apartment on Svartvikslingen is going to cost, 1.2 times the average price, whereas an apartment on Vindvägen is going to cost 0.8 times the price. And just that calculation is then going to say, based on what street you're on, it can basically adjust that. And the neural network is going to be trained with those particular values. So this is a 7-segment LED display, or LCD display. What you could do is you could build a neural network, you could actually write code that could basically understand what type of figure that is. Fairly easy. If A and not B, and C and D and E and F and G, then the number is going to be 6. And what we're doing here is we're making binary decisions. We're dealing with logic, we're dealing with ands, and we're dealing with true and false. So going into neural network and machine learning, we kind of have to unlearn the concept that we're dealing with true and false. We're not dealing with true and false anymore. We're basically dealing with zeros, with numbers between, say, -1 and +1, or between 0 and 1. So, supposing the LED display is a few years old and it's starting to look like this, what number is this representing? So using a neural network, what we can do is we can take the actual values between 0 and 1 of the kind of a percentage of light that we're emitting from each segment, and we can basically use a neural network to be able to train it and make a prediction. So in this example, I just basically put in the numbers myself, but it may predict that there's a 50% chance of this being a 6, 40% that it could be a 5, and a 10% chance of it being an 8, sort of based on what the actual values are. So the next thing about neural networks, they're not going to give you a definitive answer. You show it a photo of a cat, and it will say it's 86% certain that this photo is a cat. You're going to be getting a numeric number coming out of it. So the neurons can have multiple inputs. So you can basically feed in, the 7 segments of a 7-segment LED display, and you can get it to basically predict, whether it's going to be a 2 or not, or whether it's going to be a 3 or not. And then you can imagine, going back to, say, the VIC-20 or the Commodore 64 or the ZX81 that you learned to program on if you're as old as me. And we had these 8x8 characters. You could build logic for that. And then you get into things like handwritten digits, whereby the pixels are a bit blurred. This thing is handwritten. And there's going to be maybe sort of 28 by 28 pixels here. So it does become a bit complex. How would you write code to be able to understand that that is a 9? And this is when neural networks come in. There's basically two data sets that you start using when you're working with custom vision solutions. They're these MNIST data sets. One of them is on handwritten digits, and the other is the fashion data set, which is basically 10 different categories of clothes. So you can actually train a regular neural network with these input layers, one kind of input for every pixel on that image. I haven't shown all of them there. And then we've got a number of hidden layers, and then you've got the predictor of what type it is. When you start out, the network is not going to be trained. So it's going to have no idea what this is. So you use labeled training data with maybe thousands and thousands of these images, thousands of T-shirts, thousands of dresses, thousands of shirts, and so on. And you basically train it. You know that this is going to be an ankle boot, and you use a progress called backpropagation. And what you're doing here is you're setting the values for all of the biases and all of the weights within the neural network. So for this particular image, it's going to predict an ankle boot. Now, you can imagine that this is kind of okay. It does kind of work on these images. There is some visualization, actually, of how that works. It says demo, but I'm kind of cheating a bit. I'm just showing what this stuff looks like as it runs. And this is basically something called a multi-layer perceptron. I was thinking of writing code to do these animations myself, but some of the people on YouTube have done some fantastic animations. This is basically showing 2% of the actual connections on a neural network that is doing that prediction. And as the different pixels are firing, you can see it's making the predictions about what the actual figure should be. Now, you can imagine that this is okay if your images are going to be very, very clean. This is the actual Zalando website. This is where the data is taken from the MNIST fashion data set. So if your images are kind of like these ones of T-shirts, it's dead easy because they're always in the same place. It's going to be the same pixels that are represented when you're representing a T-shirt. However, if this is your image, how are you going to detect where the T-shirt is within that image? It's going to be in different positions. Even with, just go on here, sorry, I'm skipping back. Even with images like this, it's going to be quite challenging because all of these ones are occupying different pixels. So training a network on that, especially if it's like images of cats and dogs, not going to be possible with those linear networks. We need something a bit more complex because the kind of problems we're going to be solving in AI, there's some examples of them here. One of them is image classification, where you've got the whole photo, and is the whole photo a cat, or is the whole photo a dog, and making these multi-class predictions. The other one is object detection, where you show a photo of a cat and a dog, and it's going to identify the cat and give you a bounding box around the cat. Same thing with the dog, identifies the dog and gives you a bounding box around the dog. As you can imagine, object detection is a lot more challenging for a couple of reasons. Firstly, generating the data sets. Somebody has to draw the bounding boxes on tens of thousands of images. It's a slow and tedious process, also quite error prone in getting consistency on how accurate those boxes are. With the classification, it's a lot easier. You've just got to sort the images into folders. 10,000 images of cats, 10,000 images of dogs. You can generate that data very easily by Googling for cat in the image search and just basically saving the web page, which will save all of the images. And you've got 200 or 300 photos of cats, and that can be used in the training set. There's other things that you can do, like semantic segmentation. We've all seen this. We've been working in a Zoom meeting, and there's always one person in the Zoom meeting who has an amusing background. They're in prison or they're in a bar, and they haven't got a green screen. But what they're doing is they're using semantic segmentation within Zoom, and what it's doing is basically taking the pixels that represent a person and the pixels that are not a person. And the pixels that are not a person is just basically filling in with a prison cell or the inside of a bar. And that's why if somebody picks up a bottle of water, it's not sure whether this pixel is a person or whether this is going to be the background, and it does get a bit distorted. That's basically what semantic segmentation does. You can also do regression with vision. This was a popular website a few years ago, How Old Am I?, where you could basically upload a photo. And it is doing object detection. It's detecting that there is a face in the photo. But then we're getting a numeric value out of that face, which is going to be the age. And it's able to do this age prediction by taking, thousands and thousands of photos of people with different ages and labeling that data and training a neural network to be able to come out with the age prediction. So we need to think a bit higher level of complexity when we're working with these types of images. And this is when we get into convolutional neural networks. So this is basically a matrix, 5x5 matrix with different values shown by the color. And the process of convolution, you basically scan that matrix across the input image. And you can see that when the matrix gets to that position on the 1, it's going to give an output, because the pixels on the actual digit of the line going down start to match the pixels on the matrix. And this is what goes on inside convolutional neural networks. They look something like this. However, they tend to have a lot more layers and a lot more channels. We have our input, and then we've got these channels here. And when they talk about a 5x5 kernel, that's the actual size of the matrix that's being scanned across. Also, if it's a color image, you've basically got 3 color channels, red, green, and blue, and you'll have a 5x5x3 three-dimensional matrix that's scanning across there. And then you go into different layers. So you go into another layer, and then another layer, and another layer. And eventually at the end, to classify what digit it is, you have a linear network, which is pretty much the same as we saw in the first animation. So when you're training these, nobody really fully understands exactly how these things work. But generally, things like edge detection and shape detection are done in the early layers of neural networks. Before we had neural networks, people who were building custom vision solutions would actually manually program matrices to be able to do things like edge detection and shape detection. It was all coded manually. Now it's just trained using networks. So we detect the edges, we can detect shapes, and then we can start to do a feature detection, and we can then do the actual classification. So looking at how these things work, there's a couple of good examples again on the YouTube animations. So this is basically showing the convolution process, how we're basically scanning this particular character and generating the first convolution layer. I'm going to whiz through because there's quite a few convolution layers that are being created as we go through. And as we get towards the end of the network, we're going to actually do the classification. And what that means is basically using a regular network to decide what type of figure that is. So here they're basically doing the matching and getting the percentage as to which character it is by stamping them out like that. However, in reality, when we start working with real-world custom vision solutions, the networks actually look something like this. There can be hundreds of layers. There can be thousands and thousands of these actual kernels, and millions, sometimes billions, trillions of parameters within the neural network. So it can take a really long time to train these. You can see this is basically going through the first section of layers, and as we go through into more depth, every convolution layer is going to get more and more of these outputs. So these networks are really big, really challenging. They take a lot of memory, and they can take a long time to actually process and to tune. So in order to speed up the process, we can think about being able to optimize this. Another thing you can do with these images is music genre classification. I became interested in this watching a few things on YouTube channel. You've basically got a waveform. Music is a waveform. However, if you've worked with music and with music editing programs, if you're a musician, you will maybe understand that you can have this concept of a spectrogram. And what this is showing is frequency over time. So I think at the top they've got the bass frequencies, at the bottom it's the treble frequencies. And this spectrogram is produced by a mathematical formula called a fast Fourier transform. So various things like Audacity will be able to display spectrograms. So the spectrogram is basically an image which can be fed into a neural network, and it can actually do classification on what type of music it is. I was demoing this last week. I was actually training the network in Azure ML. I think it took about 15 minutes to train the network in Azure ML. It's a fairly quick process. And to test the actual results, what I did was I went to YouTube and found a video with different music genres. So what this is doing is basically using that PyTorch network to be able to detect the type of music. And what it's doing is it's using a 10-second sample. You can see it's not too great on predicting jazz here. And it's basically trained on 10 seconds music samples. So it basically scans through on the actual 10-second section of music, but it's getting hip-hop there. Seems to be doing that. And then rock. There is no rock as a classification. However, it's picking up that this is metal, and that's going up to 100% there. So it seems to be doing pretty well with that one. Again, folk. There is no folk music classification here. So it's trying to guess and thinking, well, maybe this is a bit like country music, bit of classical music coming in there. Soul music is not a genre, but it does classify that as disco, which seems to be fairly accurate. And it's pretty sure that that is disco. And then we've got EDM, which it classifies as pop music. I was quite impressed kind of how accurate that is. There's good scenarios like, cataloging music collections and so on, where you can actually go in and build a system. I also tested it with different genres of dance music. I went to YouTube and got 2 hours of techno and 2 hours of euphoric house music and 2 hours of drum and bass. And it was actually quite good at being able to classify different dance music genres based on those particular data sets. So the feature identification, what we're doing really is identifying things and then making a decision. Thinking about that 7-segment LED display, you've got logic there. If this segment is on and this segment, then it's going to be number 3 or number 4 or so on. And when it gets towards the end of the neural network, it's saying if there is an ear and an eye and a mouth and a nose, then it's going to be a dog. If there's a blueberry in a paper cup, then it's going to be a cupcake. However, you do get these kind of edge case images that do confuse the neural networks and get classified incorrectly. So in order to basically make things run faster when we're training the models, we can basically freeze certain layers within a convolutional neural network. So the edge detection, the shape detection, once this has been trained on a specific set of data, you can basically freeze this and say, okay, keep the edge detection, keep the shape detection, and we'll train the feature detection and the classification. And this means that instead of training all of the parameters in the neural network, we're training a section of parameters in the neural network, which means that it's going to be a lot faster to be able to train those particular models. You could even choose to do this. Only train the classification layer, keep everything else, edge detection, shape detection, and feature detection frozen. This is what they do. They do a fantastic job of in the Azure Custom Vision service. So if we drop back to the portal into Azure Custom Vision, these are a few of the projects that I have been working with. One of them is the birds classification. I didn't know this, but there is a bird which is called an Azure Jay and an Azure Tanaja. And this is basically what an Azure Jay looks like. I think it's from an Eastern European country, and we would, in the West, it's probably called a blue jay, and that's basically called an Azure Jay. I thought it was cool that you've got birds named after Azure. And we can do a quick test on this by going in and browsing to local files, and in the test section, we should be able to find the Azure Jay and take one of those. And the test has not been seen by the neural network, and it's coming out with a prediction there. 99.8% certain that it is an Azure Jay. We can also go and test it with an image that it has not been trained on. So if we go to the African oyster catcher, it doesn't know what one of those is. So it's predicting that it's an alpine couch with a 78% certainty. However, we can train it for that particular bird if we want to. It's very easy to use this actual software. You don't actually have to know anything about neural networks. So what we can do is we can basically go to Add Images, and I can browse down, not to the test folder, but I'm going to go to the train folder, and then we can go into the, let's take the Abbott's Babbler. Have we got that one already? Oh, we've got that one already, so let's take the next one. And I've been using 100 of each image. We want to keep a balanced training set, so if I select 100 of these guys, and I'm going to copy the bird name here so I don't get it wrong. Let's open those. We drop that in as a label. It's going to upload these 100 files. And then we've got the option of training the network. So when we train the network, the quick training will usually take about 2 or 3 minutes to train the network. It's very fast. We can do advanced training if we want to, and we can dedicate a number of hours to it. So if you're using this on your project, just do the quick training first, and it will tell you in a few minutes if it's going to start giving accurate results. And you can increase that accuracy by setting a training budget of several hours if you'd like to. But I'm going to go on just the quick training and click on train. And that hopefully will be done by the end of the session. You can also do things like object detection and tracking. Just a quick demo of how that works. I've got a solution here which I can run, I think. This is something called YOLO 5. Again, it's available on GitHub, and you can just basically download this. It's also doing something called deep sort, and sort doesn't stand for sort as we would think of in sorting an array. It stands for something like simultaneous object real-time tracking or something like that. You can see it's detecting a person, and it's running in real time. It's detecting hopefully a water bottle. And it will hopefully just be able to detect these objects as they move around. So you could use this for counting how many people are walking through a certain store and being able to do tracking like that. I've got a very, very poor GPU on that machine. It runs reasonably fast, even just on a very, very basic GPU. So thinking about image classification, we've been seeing in the last session how Azure has these cognitive services, and computer vision is one of these cognitive services. And what computer vision can do is it can take in an image, it can tag that image, it can identify objects, it can also provide a description of that image, a group of people sitting at a table using a laptop. Now, generative AI is basically going to switch that thing round completely. And DALL-E 2 is the most impressive that we've got so far. So if you give it a sentence like teddy bears working on new AI research underwater with 1990s technology, what it's going to generate is this as the actual output image. The DALL-E 1 was generating kind of cartoonish images. These kind of almost look like they've been set up as a photo, very realistic. And imagine what DALL-E 3 is going to come out. Maybe it's going to be generate a movie of teddy bears working on AI research underwater with 1990s technology. There is a website available for DALL-E 2. However, you can't basically free type anything. You can basically do these selections and see samples of this. So teddy bears mixing sparkling chemicals as mad scientists in a steampunk style, or as digital art, or as a 1990s Saturday morning cartoon. And you can see there's several images that it's creating there. That is really impressive, that image generation technology. It's improving so quickly, these types of technologies. Another really cool thing that we've got is text generation. Can anybody tell what's wrong with that description, that speaker bio? I didn't write Azure in Action. There is no book called Azure in Practice. I searched on Amazon. But the rest of it's correct. I've been working with Microsoft technologies for over 20 years. I've been involved in the Microsoft Azure community and a technical expert and speaker, and I'm a regular speaker at conferences and user groups around Europe. The first part was written by me. The second part was generated by an AI, which is called GPT-3. And it basically, I fed it that particular section, and I says, can you just continue that speaker bio for me, please? And it's generated that. It is really awesome technology. It's being used in, I think Autopilot uses it, same type of technology to automatically generate code. So let's see what we can do with this. Yeah, that's the one with my speaker bio. We've seen that one. So if I'm going to submit a section on CosmosDB, in this demo-intensive session, Alan will introduce and demonstrate the functionality of Azure CosmosDB. And we can fire that in, and it's just going to continue in the same style and hopefully generate a session proposal for me. This session will cover the basics as to what Azure CosmosDB is, why you should use it, differences between SQL and NoSQL databases, differences between Mongo and Cassandra, Azure Table Storage and CosmosDB. The demo application will be a web application that will include a web API service. The API service will use CosmosDB to provide CRUD functionality for the web application. Awesome. Yeah. And we can do it again, and it's random, so it will just generate different presentations for me. Yeah. Yeah. And you can just change the technology, and you can do fun stuff. Alan will set off. In this demo-intensive session, Alan will set off a number of very powerful fireworks. We'll find out. It's thinking about it. I've tested this before, actually, and the results are varied. Some of them are a bit rubbish. Some of them are some of them are hilarious. It has come up with some stuff. Oh, it's actually set a date and a cost for it. Age limit 16 plus, and the phone number. So yeah, I think it's just pulled some random text from a firework display, but it did come out with other stuff. That doesn't look too good. It came out with one where it said that Alan is a maths teacher in Manchester who's basically produced stunning firework and laser displays for the Pride Festival in Manchester, which I thought was pretty cool. Yeah. Yeah, let's submit that one. Awesome. Yeah, so I thought of some other stuff to do with it. One of them was to create a song in the style of AC/DC, but about coding in Azure. So I put in this actual intro here like that, and some of these kind of varied. This one got pushing left, pushing right. The teams are going to with me. We're going to build. We're going to push. We're going to deploy. We're going to do it right. Blah blah blah. This one came, Azure is cloud in my mind. Azure is cloud in my mind. One-way call from Azure. Make deployment work now. Make notification work now. There's another one as well. I can't see you. I can't hear you. You're the cloud that keeps me going. Azure, the cloud that keeps me going. And it's pretty good how it's able to kind of pick that it should be song lyrics. It has to think about it a while, and some of the results are a bit hit and miss, but you can try it several times and see. So this is free to register. You get a credit of so many dollars, and each time you make a call, depending on kind of how much text you're generating, it's consuming a tiny fraction of that. Microsoft has actually bought this from OpenAI, and it is coming in cognitive services very soon. So you will be able to use this kind of a generation to be able to generate concepts. They didn't want to release it to the open market because people could do evil things with this. Think about the amount of fake news that's coming out. Spamming Twitter with fake news reports about whatever you want as an automated process will be something that will be fairly easy to set up. I'm not going to fail. We're going to rock it all day. We're not going to fail. Is it mentioning Azure? Oh, because we're running in Azure, the cloud, where it's always sunny, no matter what the other one says. Awesome. And it came out. I did drop on my slides a couple of other examples of GPT-2. It came out with that one there, just in case that didn't work. I kind of like this one. The cloud is the future, the cloud is the present, the cloud is everything and always will be. It's good, fun stuff. How much time have I got left? Oh, not much. So basically, getting on to generative AI, we're going to kind of dial about, that is what they call SOTA, or state-of-the-art stuff. We're going to kind of dial back a bit and look at stuff that we can actually do on our local machines. Pix2Pix is basically doing kind of augmentation of images. So they've got several models that you can test online, and one of them is able to generate buildings from these types of boxes. So that isn't a photo of a building, it's a generated image from the actual building elements that we place on a picture. It's able to do aerial photos to a map. It's also able to do maps to aerial photos as well, using, imagine how much data you've got available on Bing Maps or Google Maps to be able to train the model to do stuff like that. Able to take labels and generate a street scene. Obviously, the gaming industry is going to be looking at being able to generate photorealistic graphics in games and so on. Black and white to color, day to night, edges to photo. And you can play around with this as well. You can download it and train your own models. But there is a website where we can experiment with how this works. So going up to the cats, that cat only has one eye because the image only has one eye, so I can draw another eye on the cat and click on process, and the cat should hopefully get another eye. My drawing skills are very limited here. So there are some random ones that you can basically see that the line drawings are generating cats. The cats one isn't too great. The handbags one is a bit, the boots one there. This is taken from like Amazon product images, able to take line drawings and convert them to photos. And then we've got the building one, where we can basically draw a wall. Oh, that is a wall. And then we can draw maybe a door and windows. And then just process. And it's able to generate something that kind of looks a bit like a building with those elements in those particular positions and so on. So Pix2Pix is actually used in the Everybody Dance Now application. And the way that they use it is to take this pose that is generated from the open pose and to be able to convert that through the Pix2Pix network into a person in the position of that pose. That's my son James, who very kindly volunteered to be the first test subject in this. So if you can do that, then what you can do is you can take Bruno Mars. You can then use Open Pose to generate not just a single image, but the actual images of Bruno Mars in each position, in each frame as he is dancing. And then you can take those poses from Bruno Mars and you can generate James dancing in the same position as Bruno Mars and then superimpose him on that. There is a video of that which I'm not allowed to show. I asked James his permission and he said it's cringe. So I'm not allowed to show that one. So I've got one with me that I will show a bit later on. So creating the source data, we're going to be basically taking a video like that, sending it through some kind of a Python script that's going to generate all of the images. You're then going to be sending the same images through Open Pose to generate all of the poses. And then you're going to be training it. So it's kind of like Pix2Pix, where instead of taking a line drawing and converting it to a photo, it's taking those actual pose image files and generating an actual person. So the network has to be trained for a specific person. You can't take, do a generic model where you can just feed in a photo of one person and generate anybody dancing depending on the photo you're in. It has to be for that specific person. And it takes about 5 days to train the model on a GPU. So I wasn't very popular at home running it's basically a gaming rig with an RTX 3090 in it. I was running it for 5 days over the summer. The thing, it's like having the hairdryer on for 5 days during the summer. When we're downstairs in the bedroom, we can still hear the thing going. Running it in Azure ML is a lot nicer because you don't have to have it present on premise. It does take a long time, as I mentioned there, to train the model. Creating the target data, you just take Bruno Mars and you basically generate the Bruno Mars poses, and then you do the transfer by taking the target poses to generate the images and then convert that into a video file. The process that's used is a GAN network, or a generative adversarial network, where we have two networks. You've got a generator and a discriminator. The generator, over time, is going to get better at producing images, and the discriminator is going to be better at telling if the images are fake or if the images are genuine. And over the timing process, both of these are trained together. The generator is then used to be able to take the input from somebody else and to be able to generate the output. So this is basically what the first image will look like. I think I can show you the training process. So these are the input images that I was using of myself, and then I converted them to the actual label images using Open Pose. So that's my positions, and the actual training process. This is kind of what the synthesized images look like. So this is starting with the first output before the network has been trained. And if I run this, you can see this is basically through every kind of training step. You can see it's got to 500 steps. I'm playing at 100 frames a second, and there's 1,000 steps. By the time it gets to 4,000 steps, the quality is increasing, and as it gets towards, say, 15,000 steps, we've got better quality. I learned so much about the training process. James was wearing, you can't even see it, it's like Darth Vader, and it says Star Wars here. There's a lot of detail in the actual T-shirt, which was it was finding really hard to pick up. and even towards the end of the training, you can't read that it says Star Wars, but you can see that it is James. And it's kind of like brewing beer. It's a big, long process, and if you get the steps wrong at the beginning, after 5 days of training, your output is going to be so-so. So you can work on increasing and getting the actual process running again. A bit about the GPUs. If you want to try this at home, tell your boss that you need an RTX 3090 graphic card. That has 24 gig of RAM. And it will take about 12 gig, I think, to load up the actual neural network. So if you don't have sufficient RAM on your GPU, then it just throws a CUDA out of memory exception. You can't go anywhere from there. You could reduce the quality of the network. If you know about network design, you could make it a bit of a simpler network. But it's really the network memory that's going to drive whether you can load the neural network. And then having 10,496 cores to actually run simultaneously, training the network is really, really nice to have on that graphic card. It actually runs incredibly fast on a 3090, faster than on some of the machines that we've got, the GPU machines we've got in Azure. I was really impressed with how quickly it runs. Unfortunately, I can't drag that box around with me and show you the training process there. So that's what I'm running it on. If you want to train these networks, tell your boss you need one of those. Have about 64 gig of RAM because it's great to load stuff into memory. And there's going to be new graphic cards coming out, but something that's really really powerful. It does apparently play Cyberpunk 2068 or whatever pretty well on that graphic card, but I've never tried that. So a bit about the actual results on the motion transfer, because I've not got too long left. I'll just run through the results and the actual process. So the first video I did was of myself, or was James, but then he won't allow me to show it. So this is basically me mapped onto Bruno Mars. So basically, it was a bit hit and miss. I think there should be some sound on this. Yeah. Some of the sections are better than others, and what I found is that you kind of need to be really matched on the same, exactly the same position, exactly the same frame rate. You can see that my head appears a bit bigger. Bruno Mars has different body dimensions to me, so it does get a bit confused in that his arms and torso are a bit longer. You can actually tune the actual poses to adjust them. There is a process that you can do there that will get more accurate results. Also, when the camera angle changes, it just gets completely distorted. The model is basically trained on the full position. If you give it only the top, it does actually detect the top there. But you can see it's just garbage that's coming out of the neural network here. It's not doing a good job at all of being able to classify that. So MIT, if we go back and look at their images, they were getting much nicer results on that, and they're using pretty much the same network. You can see that the quality there is a lot better. I think they even did the Bruno Mars sample that I had, which was, where is it, this one here, yeah. Yeah, the reason I used Bruno was they were also using Bruno for that. I'm going to try again and basically focus. Again, it's like brewing beer. You have to get the steps right in the beginning. You have to get the right set of training data. I was using, I think, about 20,000 images there for the actual training set. So it's quite a lengthy process to get the film, generate all of the open pose stuff before you can actually start training the network. And as I mentioned, it's a 5-day process to run through all of the training iterations to get the training processed. It's probably going to take a bit longer if you run it in Microsoft Azure, but it is also possible to do that. So the code is available on GitHub. If you do want to download that, you can go to the website. So here, they basically have the white paper. The white paper is worth reading because on GitHub, it doesn't really give you an indication of how to actually run through the full training process. It kind of says, run this command and then run this command, but doesn't really talk about, how many iterations you should do, what types of data sets you should use, how long it's going to take, and any kinds of guidelines like that, where the actual white paper does. They also use, I think it mentions it in the white paper, if I can find that. They actually use 2 frames. They use the current frame and the previous frame. And the reason that they do that is if you're just doing it on single images, the animation is going to be a bit jerky. However, if you use like the frame and the previous frame, you actually get the smoothness because it understands how the actual pose should change between 2 frames. And that produces a smoother result. One of the reasons why mine wasn't too great is I filmed at like 120 frames a second and the Bruno Mars is at 30 frames a second. So kind of the frame wasn't really matching. But they do talk about, I think they mention that in the paper about how they're working with this temporal coherence, I think they call it, of using the different frames when they generate the image. So definitely worth reading the white paper if you do want to check that stuff out. Okay, so on to just some final demos that I did. When I actually wrote the session proposal for this, I actually included a bit in the session proposal. This is actually me writing it and not AI writing it. I mentioned that with Alan demonstrating how a trained GAN can improve your dancing style from Andy McCluskey to Bruno Mars. One thing you maybe don't know about presenters is we don't typically build a demo and then submit a session. We submit about 5 sessions, and if one gets selected, then we have to build a demo. And then you're stuck with the problem of having to build a demo from what you promised to deliver in your session. I failed here. Does anybody know who Andy McCluskey is? Nobody. Finland's more into rock, I think, than they are into synth pop. So Andy McCluskey was and still is the lead singer of a band called Orchestral Manoeuvres in the Dark. In 1981, he became famous for his dancing style. So that's Andy McCluskey dancing, and you kind of think that that would just be an 80s thing, it would be a fad. He'd grow out of it and get on to do something else. However, 35 years later, he's still doing the same thing. And I think the most recent I could find was in, was it March of this year? He's still at it. It's a great way to keep fit, I think. You're going to break a few ornaments, but definitely going to stay healthy doing that. So my idea was, can we take Andy McCluskey and make him dance like Bruno Mars? There are some challenges that AI is not able to solve yet, and I think this is one of them. The challenge that I had really was relating to the images. What you need to be able to generate, the actual training set, is you kind of need to have a still camera. It needs to be pointing at the person. The background needs to be still as well, because the background is also going to be generated in the image. And you also need about 20,000 frames to be able to generate a model. And Andy wouldn't stand still long enough in order to be able to generate that training data, so it wasn't really possible to do that. However, we could make Bruno Mars dance like Andy McCluskey, because in the Bruno Mars video, you actually got this static background, and he's kind of standing in the same position, the background is not moving. And that basically makes for generating a fair amount of training data. So I did have a look at getting that thing running. So the first thing I did was to generate the, if I can find it, open video file and go, oh no, I've actually got that as a video rather than the actual frame. So if I go into demo vids. So the first thing to do was to basically get the training data for Bruno Mars. So I took the Bruno Mars video, and when we look at the Andy dancing, this is the Andy label that I'm going to use as the input. So that's basically captured from Andy McCluskey. You can see that it doesn't include his feet, wherever with Bruno Mars it did include his feet. Also, we kept capturing the drummer as well, occasionally appearing in it. So that was distorting things a bit. So what I had to do was to get the Bruno Mars video and then crop it. So it's kind of the same aspect ratio and the same size as the Andy McCluskey video. Then what we can do is basically do the actual training process. I didn't train that for 5 days. There wasn't really that much training data to be able to generate the full quality of the image. I think it was running for probably about 8 or 12 hours or something like that. And then we can basically map Bruno Mars across onto Andy McCluskey. So if I go into the demo videos and look here, if I go to Bruno to Andy. I haven't really pumped up the resolution much because it wasn't that great quality, but it's kind of capturing the approximate movements. I hope Bruno never sees this. Yeah, so it's sort of worked, but the quality can be improved on that quite a bit. So I think that there's really impressive stuff that we've got with this generative AI. I love playing around with machine learning and stuff. I think takeaways from what I've been talking about is it's really easy to get into AI and machine learning on the Microsoft platform now. You don't have to learn Python. You don't have to learn maths. You don't have to work with all of these big data sets and GPUs. We've got the cognitive services. So using something like the computer vision, as we've seen in the previous session, for being able to work together with, say, cognitive search to do image tagging is really useful. If you want to be able to look at the actual custom vision stuff, I think my model has trained now. It is actually saying here that it's got an accuracy of 100%. I don't believe that. I think I'm using a very small amount of training images and classes, but hopefully it will understand the new bird that we have trained. So if I do a quick test, drop down to the image URL, no, sorry, the local files, and then need to go into the actual test data to get one that hasn't been, sorry, it wasn't that one. One that hasn't been seen before, and open that one. And you can see that's coming out with 85% certainty on that, so that seems to be fine. It does also work with music genres as well. The music genre, I trained that using PyTorch, but I've also trained it using the custom vision by actually uploading the particular mel specs. And apparently, you know, that is blues, and that is disco. However, it's going to be really hard unless you're a professional musician to understand the difference. However, the performance on that was pretty good for just being able to do this in custom vision. So it's getting like 83%. I wasn't really using that many images, I don't think, on the inputs as well. So I was quite impressed that, you know, a custom vision service can actually do music genre classification pretty well. So this is great. This works really well. The challenge is, or the problem of the custom vision service is the cost when you start using it with video. I've got a video. I can't actually show this video. The last time I showed this when I was streaming on YouTube, YouTube basically blocked the content. The reason is that I was doing logo detection on a Formula 1 race. So I basically went to YouTube, I found like the highlights of the Hungarian Grand Prix, about a 5-minute video. I downloaded that. I then used the object detection to be able to identify certain logos in the Formula 1 race. And the idea was that, you know, you spend millions and millions of dollars sponsoring a Formula 1 team, and, you know, how much TV time do you get for that? And the video was basically showing how many seconds Rolex was appearing on the screen, or how many seconds Pirelli or Shell or these various other logos that were appearing on the screen. It did quite a nice job of being able to do that classification. Now, I think I worked out that if you wanted to do that for a Formula 1 race at 50 frames a second for 2 hours, it cost about $4,000 in actually making service calls, repeated service calls out to the computer vision service. So it does start to get expensive if you're going to be calling it multiple times. That's when it's useful to be able to understand a bit about working with PyTorch, working with Python, and working with a library. So I just basically use the YOLO 5 library for object detection. Again, that's available on GitHub. You can download that code and you can run with it. It's fairly easy to be able to train a model. The challenging part is actually training the data sets, taking all of those images and drawing boxes around all of the Pirelli logos and all of the you know, APS and Rolex logos on the Formula 1 race. But once you've done that, it's fairly easy to be able to train the model. Lastly, I was thinking, you know, can I do something that's a bit relevant to the IglooConf? Going back, how many people were at the first ever IglooConf? There's quite a few were here. Dan Rosanova was speaking, and he was talking about, I think I've got his session. Yeah, he was talking about Azure messaging. So would it be possible to take this video of Dan talking about object messaging? And what I did was I basically sampled or took the actual square of Dan in that particular position doing his presentation. There's a nice lot of training data there. The challenge here is that the background is changing because the camera is moving slightly. Also, some people do occasionally walk across the background, so it does actually corrupt the training data. But Dan's kind of working with his arms quite a lot, and we can get a lot of different poses of Dan. What we can then take is this. So is it possible to transfer Jim Kerry's motion onto Dan Rosanova? So again, the results, because there wasn't not that much training data, aren't that great. But I'm going to finish with this video here. Deepfake Dan, I've called it.
Hello. Thank you for having me. Thank you for being here. And I know I'm probably one of the last things standing between you and your weekend, so I'll try to be brief. My name is Dan Rosanova. I'm a program manager at Microsoft on the Azure team, and I'm responsible for a lot of the messaging services with my team that I've actually heard quite a few people talk about this week, so I'm pretty happy about that.
There you go. So I'll end with that. Excellent. So thanks for listening to the session. If you're interested in like the custom vision AI, drop onto my YouTube channel. I've got plenty of videos talking about custom vision and computer vision. And I've been reminded to mention about the URLs for the evals for day 1 and day 2. And to round off the IglooConf, I think we can all agree the cloud is the future, the cloud is the present, the cloud is everything and always will be. Thank you very much.
All right. Thank you, Alan. Please keep it visible for a while. So some people have left. That's understandable. And thank you for the stream as well. It's Friday. It's weekend. It's ahead of us. We can be with our loved ones and so forth. Please answer the survey. azure.ly/SD1 and SD2. And if some of your friends already left, maybe remind them to also answer the survey so that we can check those things out and what we can improve next time, since we really want to keep these IglooConf events happening. Very happy about these 2 days. It was lovely speaking with you all and hope to see you again soon. Have a nice weekend and thank you to you and thank you to stream. Cheers. Bye.
Thanks.